Hi, welcome to Unity 6 LTS course. In this course, I'll begin Unity 6 from scratch, and it's very useful for those who want to start learning Unity, and also the users that already know the Unity and can work and want to learn Unity 6, the latest version of the Unity 6. I'll begin from scratch and cover the core of the Unity, C# scripting, lighting, particle systems, the differences between URP and HDRP systems, and also traditional Unity architecture, shader design, optimization techniques, and so on, completely from scratch. Also, I'll upload the complete course, the full course on the blackcave.com store that you can access the complete course, and also it includes bonus chapters. Also, you can get access to other courses related to the 3D rendering, 3D modeling, and also game development. You can get access to many tutorials and extra chapters, advanced chapters of this course. Also, at the final, you can get a certificate and add it to your resume. Also, the link is in the description. Here, you need to visit to the unity.com website and go to the download section. And then navigate to the subscription plans and go to the personal section and press the learn more. We need to download the free version and get the free and personal license for it. Here we can press the get started to download the Unity Hub and get the license of the Unity Personal, or go to the Unity 6 and press the download the latest. So here press the get it latest, and here we need to press the download for Windows. If your operating system is different, a Mac or Linux, you can download them with these links. Here, press the download for Windows. Right. After installing the Unity Hub, I already have it on the system and I didn't download and install it. The installation process is easy. After that, it will face with this screen, and you need to create an account on the website. It's easy. You can insert your information and create a Unity account, or you can sign up using your Google account, your Gmail, and it's easier than the other ways. After that, you need to sign in. Let's press the sign in button. Alright, here you can also create an account, and you can insert the email you've inserted in the creation account process here and sign into your account, or you can continue with your Gmail. I will choose the Gmail. I will select one of my Gmails. Here you need to accept the Unity terms of services and continue to work. Alright, whenever you signed in successfully, you face with this page and you need to press Open Unity Hub. It will redirect to the Unity Hub and open your user token inside this application. Here you need to press this button to accept the terms of use and get a personal license. You can read about the personal license of Unity in detail in its website. In the personal version, you have some limitations, and if your game sells a specific amount, you need to get the pro version of Unity, and you need to pay monthly and give a specific percentage of your project purchases to Unity company. Here we have the Unity app as a tool, as a software that you can manage your projects, which you can see I have many projects here, and also you can manage your Unity license, Unity versions, and download the Unity engine, and also tools like SDK, JDK, which is useful for Android exporting, and so on. Here you can see all of my projects and also the Unity version I use for them, and also the date I've opened them. Here we can switch the Unity version. These are the unit versions I have. You can switch between them and open the projects using the other versions. Here we can navigate to the installs and install a new editor, and also you can locate an existing editor, Unity editor. Also, you can manage your Unity editor, can add extra modules. Here we can add Android build tools, supporting for Linux, supporting for PlayStation, and so on. And you can easily install the current version, a specific version of Unity. If you download and sign into the Unity app, actually you don't have any Unity installed on your system. You need to press the install editor and install one of the Unity versions. We have Unity 6.1. It is, as you can see, it is supported and recommended. You can install it, or you can install the previous versions, which is LTS. LTS stands for long time support. It is the most stable version of Unity, but the recommended version is good as well. Also, you can download the previous versions that is still supporting by Unity, for example 2022, 2021, and they are LTS. You can press the install, and the installation process is very easy. You don't need to involve too complicated process. Also, here in the settings you can change the path of your default projects and also your Unity versions. For example, my default project path is here, and I can change it, and also I can change the default location of the Unity editors here, and also we can change the downloads location. Download means a file that includes the Unity editor itself will be stored somewhere on your PC, and if you delete the Unity with any reason, you can install it later again without downloading, and go to the locate and locate to the installed Unity. Also, you can go to the learn and watch the videos and read the documentation and learn many things about Unity. All right, the most important part is these two buttons. This is the new project button. We can create a new project from scratch, and this is the add button. You can add a project from your disk, your PC, or from a repository. Which means adding from GitHub. For example, if you don't know about a GitHub, GitHub is something like a cloud hosting that gives you a free space, free storage that you can upload your project safely. No one can't access to the project except you, and you can download the project from that repository, from that host, by pressing this button. And GitHub has many extra features that I'll explain it later. Let's press the new project. Well, consider we don't have any project here and it's empty. We press the new project. All right, here in this window we need to select the Unity version. We have these editors. I will select the 6.0.4 because it's LTS, long time support, and it has more stable features and attributes. And here we need to select the type of our project. For example, you want to create your game for mobile and small devices, you need to select the lighter version of the Unity. Here we need to select 3D Mobile or Universal 3D and so on. Also, you have other projects, for example, for AR, VR, and here for FPS games, 2D platformer games, and so on. We have two options here, but the most important is Unity is three main sections: Universal or URP, High Definition Render Pipeline, and also the basic 3D scene. We have 2D also, but in the 3D project we can access the 2D as well. The 3D project is the vanilla or the traditional Unity that you can access to the basic structure and the basic tools in the Unity. But the new generation and the new tools are exist in the Universal or URP and HDRP. But HDRP, which is useful for realistic graphics, has more tools. So we will work and cover the high definition render pipeline instead of URP or the vanilla Unity. So we need to select the core. Core means we don't have any sample project here. We can download the HDRP version with samples, but we will use the core or basic or empty project of the HDRP. Here we need to select our organization or account, and here we need to enter a name for our project and select this to store the project on our PC, not Unity Clouds. And here change this to Unity course beginner course. And next, change the location if you want. Here I need to create a new folder and rename it to Unity beginner course and select this folder as the default location of the project. Here we can select the use Unity version control, which is a system like GitHub that you can upload your project on the Unity Cloud, and every change you will apply on your project, it will upload and change on the cloud as well, and you have backup of your project. All right, good. Press create project to create a new project for you. This process take a while. It needs to download some packages and compile some codes and shaders that I will talk about. Alright, now we are in Unity and let's navigate through the UI and explain some important sections. At the top here we have some menus that some of them are common in many software, for example file edit and window help, and these four menus. The other menus, assets, game object, component, services, are new and available in Unity. First, let's start with a file. We have new scene and open scene here. Every environment in Unity is defined as scenes. We can create a game with just one scene or a lot of scenes. Here we can create a new scene, open a existing scene, and also we can save or save as scene. Also here we can open a project or save a project to save the imported resources, and also here we can add a new project. And here we can exit the Unity. In the edit menu we can access to the undo redo, Control Z and Control Y, which we can redo the history or undo the history, select the elements and the objects in the scene. I will explain about the scene and the objects inside it. copy, paste, cut, duplicate, rename, delete, and many other features that I'll explain later. I can't explain one by one now because they are related to the 3D view, and I need to explain the 3D view first. The next menu is assets. Assets mean all the resources that is compatible and usable in Unity, such as audios, 3D models, textures, codes, and so on. Here in the create menu, we can create any asset we want. For example, we can create a subfolder in Unity. I'll explain about it. Material, which is the coloring features for the 3D objects, a code, a script, animation, audio, and rendering stuffs, and so on. I will explain it in detail. Also, we have some operations, for example, refresh, import assets, and so on, that are related to the assets stuff. The next thing is game object and component. First, let's explain about these two features. What is the game object and what is the component? Here we have a 3D scene. Every entity in this scene is a game object. For example, a camera, a ground, a 3D model, everything we imagine is a game object in the Unity. Outside the 3D scene, that's not a game object. We call it game object just in 3D scene, 3D view. Anyway, everything can place in 3D view, the 3D scene is a game object. So, what is a component? Actually, components are scripts or codes that we write or Unity created earlier, and we can attach infinite number of components to a game object to add features to that game object. For example, we have a character which it doesn't have any weapon on its hand. So we add a weapon component, and now the character has a weapon, and then we add another component to fight against enemies. So our character has a weapon and also has the combat and fighting ability. We can add extra features, for example, flying component to add a Superman-like ability. These components find features and abilities for the game object. We can say anything in the scene is a game object, and the game object, and we can add a lot of attributes to the game object using the components. We have many types of components in Unity. Every component is a predefined by Unity itself. You can add a lot of custom components easily, which every component is a C# script that I will explain about it and deep dive into the C#. We have services here. We can get help and support from Unity. I'll ignore some menus that are not so important as much as the others. In the window, we can access and manage the sections provided in Unity. For example, we can access the general window, rendering window, animation, and so on. For instance, we have a 3D view and also we have a game view. You can access both of them here in the general scene game. Right, now the main part is this 3D view. This is the main 3D view of the Unity, and also if you choose a 2D project, you will face with a 2D view. And here in this panel, you can access the game view. A camera in the scene represents the game view and the player view, and I specify which type of camera used in your game. For example, FPS or first-person shooter, first-person character, third-person character, isometric camera, top-down view, which is very useful for strategy games, 2D view, and so on. Here, hierarchy section, we have a list of game objects in the scene. As you can see, this is the main and root scene, and here we have a camera game object in the scene, and as you can see, this is the camera logo, sunlight, and also the sky and fog volume, which specifies the attribute of the lighting, the atmosphere, adding fog and mist, and so on. And this is here. In the 3D view, we can rotate the camera by holding the right click, and here we can rotate the camera and see the environment easily. Also, while you're holding the right click, you can navigate and move using the WSAD. Easily you can move like a video game. Also, you can hold the shift key to increase the speed. If you're lost in environment, just like me here, you can click on one of the game objects here, for example, camera, and press the F key to focus on it. And in this way, you don't get lost anymore. Alright, you can zoom in and zoom out using your scroll and also Alt and right click. And here you can zoom in and zoom out easily. In the right side, we have the inspector, and you can easily access to the attributes and components of every game object in the scene. For instance, if you select one of these game objects or select in the 3D view, like this game object, you can access to all attributes and components. I will explain it in detail in the next chapter, and I can say this is the most important part that you see in the game development process, and you work with it. The next part and the next important part and window is the project window, where your files and assets and scripts placed. Here we have a vertical view of your folders and assets, and this is the horizontal view and with big icons. Here we have two folders, a Unity scene. The Unity scenes are look like this. An object, I will explain about objects, and you can add many other files and folders. You need to right click on the empty view, and here we have many options. For example, show in Explorer will open this folder, this environment, in the folder view of your operating system, no matter it's Windows, Mac, or Linux. For instance, right click on this and show in Explorer, and here we have the folder view. You can open an asset. For example, if you have a C# script, you can right click on it and open it. You can copy the path of the asset, import assets, for instance 3D models, textures, audios, and so on. I'll explain about packages in Unity later. You can refresh your assets or re-import if, for instance, you've applied some changes to a specific asset, and you can re-import it or re-import all the assets. Right click on it and re-import it, or re-import all to re-import all these assets. You can open the selected C# script and so on. Here in the create menu, I can create a folder material for the colors of the objects, 3D objects, a C# script which is named mono behavior script, and you can add many assets here. I can't explain all of them in this video because some of them are not so important as the others, and also I will explain the important ones we want to work in the other videos in the future video. But let's start with the folder here. For example, I'll name it scripts, and here I can add my scripts and create my C# scripts in this folder. And you need to organize your project. You don't have to name your folders based on the Unity recommendation. All the name you will put on your folders are arbitrary and custom, and you can organize your files freely. For the last part, I need to say that you have a sign in icon here. You can sign in to your Unity account. I didn't sign in already because when you open the Unity Hub and open your project, and if you don't access to the internet connection, it won't recognize your token and your connection, and a sign in icon appears here. But if you had a connection, internet connection, and also logged in your Unity account, here in user icon will appear. Here we can access the asset store, Unity asset store. You can access to many free and premium assets provided by Unity. You can access the asset store web. It will be redirected you to the Unity asset store, and you can see the list of your current assets. Also here you have the Unity version control. As I said in the previous chapter, you can upload your project on the Unity cloud, and every change you will make on your project will apply on the main project on the cloud as well, and you can get access to the new updates in another computer, or for instance, your teammates can access to the latest updates you make on your project. Here you can search for the menus and some assets you want to find. And here is the layout. You can change the layout and the UI of the Unity. For instance, you can select 2x3, and here this is the layout for a split default. This is the default view I use, tall, wide. And also you can save your desired layout and load the layout later, or delete your layout. For instance, I will drag this inspector easily here, and I will save this structure, or you can place it here, everywhere you want. In the future chapters, I will explain about the console. Console is important, very important, but I didn't want to explain it in this chapter. Actually, it's not related to this chapter. In the next part, I will explain about the components and game objects in detail. In this chapter, I will focus on the components, game objects, and moving, rotating, and scaling them, and also adding other game objects to this scene. Here, as you can see, we have 3 game objects in this scene. You can add more game objects. You can import your 3D models to the project and add them to the scene. Also, Unity provides some basic and primitive 3D models that you can go to the game object, and here in the 3D object we have cube, sphere, capsule, cylinder, plane, quad, and mirror, and these are the 3D objects, primitive objects in the Unity. Let's add a plane, and here after that let's add a cube to the scene. Alright, cube is here and we need to move it. I'll explain the move tool. Alright. The question is how to move an object, or rotate it, or scale up or scale down the object. You can select the object you want to move here or here and press the W key on your keyboard, or select this icon, and here we can move the object. This is the Z-axis, as you can see here. The blue cursor is the Z-axis, this is the X-axis, and this is Y-axis. In some other software like Blender, the Z-axis is up and the Y-axis is front, and it's different from this view. I just wanted to say all 3D software doesn't provide the axes and directions like Unity, but X-axis is similar to the other 3D software. Next, you can press the E key or select this to rotate the object. Here we can rotate along the Z-axis x-axis and y-axis. And using the R key on your keyboard or selecting this, you can scale down or scale up the object in any direction you want. For example, Z, Y, or X. Or you can drag the center of them and scale it up or down in 3 axes. The direction is similar. You can drag the center of it or moving. But in the movement mode, you can move in 2 directions, not 3 here, which z-axis is not included. Here the x-axis is not included, and here the y-axis is not included in this movement. Also, while the object is selected, you can see a component called transform. Let's collapse the other components. I'll explain them later, but we have a transform component here, which all the game objects in the scene have this component. Here in the possession, you have the X, Y, and Z, and you can move the object in the x-axis by dragging this field or this field or this. And for the rotation and the scale, we have this capability as well. We can type a value, a custom value. We have many options to rotate, move, and scale our objects. Also, I need to say each square in this grid is a 1 unit. And here, if I insert 0, you can see the cube is here. And if I insert 1, as you can see, just 1 unit per each square it will move. And this is the principle of 3D views. Here in the scale field, we have this icon. If I scale it up along the x-axis, you can see the shape, the entire shape is changing. But if I enable this, if I scale it up along the x-axis, you can see it will change in all directions. And we have the same structure in the Y and Z and also in the 3D object. These axes are disabled. And if I hold and drag one of them, the other will be changed. Also, if you don't want the grid, you can disable it. Grid is here and you can disable it or change it. Here you can change the grid direction. Here's the Y. You can change it to X. You can change it to Z. And also you can change the opacity. But I don't want it in this scene and I can disable it. Here let's place it at the center of the plane and scale the plane. Plane 3D model is the simplest 3D model in all 3D software, and it's very useful to make walls and floors. And the most important part is the plane has one side. If I go down, and you can see we don't see the plane, and actually it has one side, and it is very useful for optimization. Two sides make the object heavier to compute. Cube also is not too complex. Actually, I'll focus on the 3D objects and structures of them in detail later, and what factors make a 3D model heavy to compute. Let's add the other 3D models, primitive 3D models, the sphere here, the sphere, and this sphere is heavier than the others to compute. You can scale it up in the x-axis, z, and y. The next is the capsule, and this is heavy as well. Heavy mean heavier than cube or plane. Cylinder and the other game objects are not so important. For example, mirror is just like the plane but with reflection capability. We have many other methods to add reflection to the Unity and I don't use this game object. Alright, these are the basic and primitive 3D models and the basics of it. Now let's delete them and focus on the components. Welcome to part 4, Unity 6 course. In this chapter I will explain about other game objects such as lights, audios, and so on. And I want to deep dive into the components. Actually, as I said in the previous chapters, components are actually scripts, C# scripts. You can add your custom C# script as a new component, new custom component, or use predefined components provided by Unity. Here in the game object, we can access to many type of game objects. For example, effects like particle system, system for creating a rain effect, dust, snow, and so on. Here we have the lights. I will explain it in detail. And this is audio. The most important part is the audio source. We can play a 3D or static audio in the environment. We can add video player. Here we have UI or user interface. For example, if you want to show the health of the character, the name of the character, and so on, the buttons in the menu, in the main menu, we need to use the UI. I'll try to introduce the most important game objects. Here in the volume, which is an advanced concept, we can add post effects, actually the camera effects, and also we can add fog, mist, and so on using the volumes. Here we have the camera, a simple camera that I will introduce it, and these are the most important game objects in Unity. Right, in the scene, by default, we have a light and a camera. Let's delete them. I want to add the lights from scratch. Here, we need to go to the game object, light. We have 5 types of lights. These are the lights. The rest of them are not actually lights. They're related to lighting. They help to add better lighting. The first one is the directional light. It mimics the sunlight. Here with W, we can move it, but moving it doesn't affect on the scene. The rotation of it is important. Press E and rotate it. And as you can see, we have many effects, many sound effects by rotating it. And you can see the direction of the light here. At the right side, in the inspector, actually know about the transform component. It will help you to change the transformation of the object. Here you can move the object, rotate the object, and scale the object. I explained it in the previous chapters. The next component that a light game object has is light. You can uncheck it to deactivate the light component, not the game object. You can disable the game object using this button, and as you can see, it's the text color is gray, not white like this cube or plane, and you can set it active. Here in the light component, we have many sub menus. Let's start with general. You can change the type of the light here. Instead of adding the lights from this menu, you can change it directly, but I don't want to use this option. Here you can change the mode, the light mode. We are in real-time mode. Actually, real-time means if you rotate it, you can see its effect instantly. But for example, if you use baked, you can't see the result instantly, and you need to bake the light to this scene. And actually after that you can remove the light because the light effect has been applied to this scene. I will explain it in detail later. What is the baking process? And mixed is the both of the bake and real time. Actually, baking is very good for mobile games because it will remove the complexity and the calculation of the lights and add aesthetic lighting to this scene. Right, I will ignore the rendering layer. The next is the shape. Actually, we have a parameter called angular diameter. Here you can make the light focused or spread it. Here, as you can see, let's see the surface. Here we have a little change. As you can see, it's more spreaded with higher value of angular diameter. And this is focused. This is very helpful when you have shadow. We don't have shadow applied for this slide. I will change this parameter later when I activated the shadow. Alright, in this section we can change some attributes. They're not so important. Actually, this is kind of new in Unity 6. Here, for example, let's change the flare size. As you can see, the size of the sun is growing up by increasing this value. Or you can change the flare fall off. For example, let's see here. As you can see, it's not smooth. Here is smoother, but this is not smooth. You can make it smooth by increasing the flare fall off. And also you can change the light of the flare. And you can reduce the flare multiplier, a value that multiplies by the flare size and flare power. Actually, this section is related to the light effects, not the power of the light or shadows, not the light itself actually. The next is related to the light color and light power. Here we have two methods to change the color of the light using the color directly or filter and temperature. For example, in the filter you can change the filter of the light, and actually we're changing the color, or you can use the temperature. For example, a cooler color or warmer color. Actually you can change it to color, just color here, just like the filter. But the latest way to change the color is the filter and temperature, because you can access the filter and temperature with each other. For example, you can change the light color with the filter and change the temperature later if you want. The next is intensity. You can change and adjust this slider, and you can see a small logo here. For example, this is sunny. You can see the weather here, or you can select it and select one of these weather status. And also this number is related to the intensity, and you can change it manually. You can increase it and set it to whatever you want. The next attribute is indirect multiplier. It's related to for example, this area where we don't have the light applied on the surface because the direction of light is this direction and we don't have lighting here, and indirect lighting adds an ambient light on the shadowed areas. Alright, I don't explain the other attributes because they are actually advanced and not good for this video. Actually, I will ignore the volumetrics. It's related to the adding atmosphere, fog, and mist to the scene, and I didn't explain about the fog and mist, and I can't actually work with the volumetrics right now. The most important part is the shadow, and you can activate it, and you have this effect. You can change the rotation and see the result. You can change the update mode. Every frame means if we have 30 FPS or 60 FPS per second, so we have a 30 updates for the light per second or 60 update per second for the shadow of the light. It's heavy, but it's the most powerful updating method for the lights. If you change it to on enable or on demand, especially on enable, if you change the rotation of the light, you don't see anything because it's not update frame by frame. If you disable it and enable it, as you can see, the shadow changed. On enable means if we disable light and then enable it, the changes will be applied. Alright, let's change it to every frame. You can change the resolution of the shadow here. This is low, this is medium, and you can see the pixels provided by the shadow, high, and ultra. We have a very detailed shadow. It is very good, and you need to set it based on your preferences. You can change it programmatically and implement a settings for the quality and then change it in game. Maybe I'll cover it, and this is a good exercise to work with the quality of the shadows. Alright, the next thing is normal bias. You can change actually the length of the shadow a little here. Let's keep it as is. Dimmer, actually it's opacity of the shadow. Here you can change it, but I prefer to use 1. It's the most realistic result. And actually you can change the shadow color, and black is good. Alright, the rest of the attributes related to the shadow hardness, shadow spreading, and so on. For example, the first attribute makes the shadow harder if you set it to a low value. As you can see, this is so hard edges, and this is smooth. The next attribute will make the shadow spreaded and also hard edges if you set it to a low value. The next is min filter, and you can make the shadow smoother if you set it to a high value. Actually, you can't make it harder by reducing it. You can make it smoother only. But the best way to make the shadow smoother is radius scale. Here, this is better because we don't have artifacts. Actually, min filter makes the shadow smoother in another way, in a different way, but radius scale is the normal way to make the shadow smoother. And you can make it smoother based on your needs. For example, based on the weather. In a sunny day, this shadow is realistic, it's good. But if the weather is rainy, you can make the shadow smoother just like this. I will ignore other attributes. They're not so important as the others, but let's explain about the angular diameter. If you increase it, you can see the shadow is smoother. It's different from this radius scale, but it will affect on the shadow as well. Actually, it will affect, and as I said, it will spread or focus the light, but actually it will affect on the shadow as well. And the next thing is indirect multiplier. Actually, it should apply in indirect lighting and ambient lighting to these shadowed areas, but we can't achieve it because we need to activate the baked color, not real time. And actually in this video I don't want to explain about the baking lights. Alright, we're done with directional light. Let's add, I don't want to explain about directional moonlight. Actually, it's a sunlight or directional light with a different color. Let's focus on point light, which is look like a bulb. And this is the point light. Actually, it's look like the bulb. Point light will change based on the transformation, not rotation and not scale, just if you change the position of it. Here we have many attributes that you're familiar with. Here you can change the type, change the mode, real-time or baked, and so on. Here we have radius. It is look like the previous slide, the directional light. Actually, the name of it's different, but application of it's actually similar. It will spread or focus the light, and I will explain it when I explain the shadows. In the emission, you can change the color of the light, temperature, intensity. Let's increase the intensity a little. And we have a range. This is the range. You can change the range by pressing this yellow node and dragging it, or you can change it manually using the range. Here in the indirect lighting, as you can see, we have a warning, and it says you need to use directional lights to add indirect lighting to your scene, or you need to set this light to baked and then activate this property. I don't want to use it, and actually I need to change it to 0. Alright, I will ignore the rest of the attributes, but this section in intensity multiplier is a value that multiplies by the intensity, and you can increase it instead of increasing the intensity. You know about the volumetrics. Actually, I don't want to deep dive into it because I didn't explain about the mist and fog. In the shadows, I can enable the shadow map here, and we have a different angle by changing the position of the light. You can change the update mode, resolution. You know about the tint, dimmer, normal bias because I explained it in the directional light. And also we have a value here, fade distance, where we can change it, for example, to 10. And when you go further in the 10 actually meters in Unity units, you can see the shadow fades. But when you increase it, you will change and you will increase the fade distance of the shadow. It is very useful for optimization, and you can change it based on your needs. For example, in a game, when you get closer to the objects, you will see the shadows are appearing, and actually in some cases the resolution of the shadows are changing by getting closer to them. In the high quality settings, you can change some attributes. The most important part is the radius scale. You can make the light smoother or harder. This is very useful for this working, and we had this option in the previous slide. The next option is the contact shadows. While we had the contact shadows in the directional lights as well, they will add micro shadows. When we get close to the object, we can see the micro shadows. Here, let's activate it by checking this or set it to low, medium, or high. Let's set it to high, and here let's change the position of light and see this area. As you can see, we have a micro shadow here, and actually you can see a hard shadow, a hard micro shadow. And this is very useful when we want to achieve a better result. Alright, now we know about the point light. Let's explain the spotlight. It is look like a projector or a flashlight, and here we have some different attributes. You know about the general menu. You can change the shape. It is cone, you can change it, or box. I prefer to use cone, and you can change the inner and outer spot. Here we have a bigger spot, or you can change the spot using the nodes, the yellow nodes, or change the depth of the light, and actually the inner cone. And let's change it here. Let's change the position of the light. And you can change the radius, just like previous lights. Here we can make it spreaded or focused. Here we have the emission. Let's pick a warmer color and change the intensity. We have a previous warning for the indirect multiplier, indirect lighting, and here with the range we can change the depth of the light. Alright, the emission just look like the previous lights. Let's work with the shadow map here. Let's enable it, and as you can see, we've applied the shadow on the scene, and you can change it by changing the position of the light. And actually the rotation is effective in this light. The attributes are similar to the previous parts, the shadow attributes. I don't want to explain them again. Actually, we have radius, scale, enable, contact shadow, fading distance, dimmer tint, and so on. We don't have any special differences which I want to explain. Alright, this is spotlight, and it's similar to actually point light. The next light is area light. It is not very useful. It will apply light based on a shape. It is kind of different from spotlight. You can change the shape of it. For example, like a bulb here, and the effect of the light is the bottom. You can change the rotation, and as you can see, the shape, the entire shape is changing. Here in the shape, we can change the shape of the light. It is a rectangle. We have the size X and size Y. We can change it to tube, and here this look like a line or disc. Alright, here we can change the emission settings, the range. It is different from the shape, and the rest of the attributes are similar to the previous lights. In the shadow we have a different system. We just have baked shadows, not real-time shadows. Actually, I didn't explain about the baked shadows, and as I said, it is very useful for optimization, especially for mobile game. And actually, you can't achieve shadow by enabling it. As I said, area light, it's not very useful. Actually, in many cases, spotlight, point light, and directional light are enough. Actually, area light is very good for representation. For example, you want to represent a character or a kind of special object, and this is very useful for those applications. Alright, let's add a directional light. It is better, and enable the light. These are the lights I explained in this chapter. I will deep dive into the camera, audio, and so on later, but let me add a camera and audio just for beginning this concept. Let's explain the camera. Here, camera, I don't want to deep dive into the attributes of it. It has many attributes, but I want to say if you select the game mode, you can see the camera view. And here, if we delete it, you can see a message that says no cameras rendering. Here we can change the position of the camera or rotation of it and see the result. Also, we can change the camera view based on your current 3D view. Here you can change the position or rotation of the camera and set it to whenever you are in the viewport. You can select the camera, go to the game object, and align with view. And as you can see, the camera is here. And here we have this result in the game view. Actually, game mode, game view is related to the camera. If you don't have any camera in your scene, you can't play the game actually. Here we have many options that I will explain it in next chapters. And the last and one of the most important game objects are audio source. Here we have a audio source component that it has many attributes, But important part is you can assign any type of audio to your audio resource. WAV or MP3 type are kind of common, and you can import your audio files to your project and add them to the audio resource field. This is the most important field. If you don't have any audio file, you can't actually play the audio. You can change the volume, you can mute the audio, you can loop it. If it ends, it will play again and again. And we have many other attributes. Right, I explained about many important game objects that we will use a lot in Unity. In the next chapter, I will start the scripting, the C# scripting in Unity. And I will deep dive into other components, adding custom components. For example, we can right click on this component and remove it, and actually we have an empty game object. We can press add component and add an audio source manually to this game object. Actually, this is the main property of the Unity engine. It is very useful. Actually, everything in the Unity is an empty game object, and we will add predefined or custom components. In the next chapter, I will explain about them. Welcome to Unity 6 Part 5. In this chapter, we will explain about the components and how to create custom components using C# scripts in Unity. In the previous chapters, I've explained about game objects and the concept of game object. Everything in the Unity scene is a game object. This cube, this light, camera, and everything in the scene. But we have different entities. As you can see, the light is just an icon, and actually the cube is 3D. What turns a game object to a cube, to a light, to a camera, to an audio? Actually, as I said, the components. As you can see, all of these game objects have a common component, transform, which defines the transformation info of the game object in the scene: position, rotation, and a scale. Actually, we can't right click and remove the component, but for the light component, we can right click and remove component. And actually, this light is an empty game object right now. Now it's light because we have the light component. So we've add a component to an empty game object and convert it to a light. So components actually convert a game object to a specific entity in the scene. Transform is the base component, and we can't remove it, and we can't add another transform. It's impossible. Actually, in Unity, we have a useful subject called empty game object. Actually, this empty game object has a transform component, not any other components. We can add any component we want. For example, light, physics, a cube, a camera, or even custom components, custom C# scripts. Actually, a C# script is a component. A C# class is a component. I will explain about the class and add many properties by adding components to a game object. For example, here let's search for the light. And here, as you can see, our empty game object now is a point light. General is a point light. We can change it to directional, spotlight, and area light. And here, let's increase the intensity. And disable the directional light. And as you can see, we have a point light here with just a component. We didn't add a light from here. Actually, we've added a component. We have many predefined components provided by Unity. But actually in this chapter, I want to explain and start the C# scripting in Unity. And I want to add our custom components. I've created a scripts folder, and I'll create my scripts in this folder for an organized hierarchy. I will use folders, right click and create, and here we have a mono behavior script. It's an actually C# script, and here I need to rename it or leave it as is, and the name will be new mono behavior script. Let's change its name. For example, simple code. As you can see, we have this progress bar compiling scripts. It will take a while, actually 10 seconds, for example, and we're ready to write our codes. Right, after the code has been created, you need to open it in a code editor. We have many options. For example, Visual Studio, VS Code, Rider, and many other options. You need to go to the Edit and Preferences. And here in the external tools, you can change your code editor here in the external script editor. Here, Visual Studio 2022 has been selected for me because I have it. Here we have Visual Studio Code, and if you can't find your desired program, you can browse it. For example, you want to open your scripts using Notepad++, but using Visual Studio 2022, you have a better auto-completion, and actually everything is ready for you. You can open and write your codes. You don't need to add the custom configurations manually. Actually, you can download the Visual Studio Community version for free and download it from Microsoft website and start writing codes. Here, I need to press the assets and open C# project. Actually, if I right click on this file and show in Explorer and go to the actually root path of the project, as you can see, we have a Unity beginner course.sln. It's this C# solution file, and you can open this file directly by double clicking on it. Actually, opening this file is equal to assets and open C# project. It will open the C# solution. Right, let's open it. Actually, with this method, all of your codes and the features of your project and the C# scripting in Unity will be opened for you. Alright, as you can see, this is Visual Studio, and actually we can write codes here. Our project may includes many C# scripts. One script, 100 scripts, 1000 scripts, and more. Doesn't matter. Actually, you can create many scripts you want. To open this simple code script, you can double click on it and it will open in this window. Or you can go to the Solution Explorer and under the assembly C#, assets, and scripts, just like this hierarchy, you can open the simple code. I don't have any different. Right, here we have a structure. If you don't know about the C# and coding and how to write the codes, you need to first learn about the C#. I tried to explain about the C# scripting in Unity from scratch, but for very from scratch C# tutorials, you need to watch other tutorials, and actually I'll try to record a C# specific tutorial for beginners. Here we have a structure, a predefined structure. We have a method called start and we have a method called update. Actually, in a simple word, everything you write in the start section, start method, and If you play the game, the codes will be executed at the start of the game. And this method is useful for starting the project and will execute once, not several times. And what is the update? Update actually execute everything inside this block, this update method. It will execute infinite times until your project is running. Maybe you heard about the frame per second or FPS in games. Actually, a game runs in 30 FPS per second. A game runs 60 FPS per second. A game runs even 120 FPS per second. Actually, it's the update method. Everything you write in the update method, if your game is 60 FPS per second, it will run 60 times per second. For example, you have 100 lines of code in this block, and they will run 60 times per second. So you need to be careful and don't write complicated codes in the update method, or split your codes, which is advanced, and you need to create a scheduler and make your codes splitted, and don't run all your codes once frame by frame, and you need to split the codes. This is advanced and I will focus on it later. We have other predefined methods. Let's write void awake. You can actually write awake, and here the IntelliSense system or auto completion system of the Visual Studio that integrated with Unity can complete it for you. For example, you can write awake and it will add it automatically to your code. Private void awake. Private, actually I will explain about the private if you don't know about the C#. Actually C# programmers completely know about the access levels, but I will explain it later. Awake actually execute everything inside this block before starting the project. Actually, if the process of the game starts, everything inside awake will be executed, and after that start comes to the game. After that, update will start its execution and process. We have many other predefined methods, for example, late update, fixed update, on trigger enter, on trigger exit. We have many methods, but I don't want to introduce all of them right now because we will work with them step by step as we need it, and it's not correct to introduce all of them in the first chapter of the C# scripting. Right, where does all of these methods come from? Actually, they're coming from MonoBehavior class. Everything in the Unity is class-based. Actually, you need to know about the object-oriented programming and classes to learn Unity well. As I said, every script in Unity is a component. Actually, it's wrong. It's a simple explanation. It's not good for those who want to learn Unity seriously. Every class inherited from MonoBehavior class is a component in Unity, and you can add that script and component to a game object. So wherever you face with this sign in C#, and before this sign is a class, and after that is another class, so we have an inheritance process. This class, this is the custom class, my class, is inherited from MonoBehavior. So all of the variables and methods are inherited from this class. This class is provided by Unity and offers many attributes, and the most important attribute is turning this current class to a component that you can assign this component to every object in Unity. I don't want to deep dive into this class right now. Actually, we are learning the principles and main concepts of C Sharp, and I don't want to involve advanced features, but I want to say the update, start, wake, and other predefined methods are come from mono behavior class. So, what's the process of signing the script to a game object as a component? Here, if I press Ctrl S or Ctrl Shift S, if you have several scripts, we just have one script, single script. If you have several scripts, you need to press Ctrl Shift and S to save all of them. And this store will be disappeared when you press Ctrl S. It means we don't have any changes and the C# script has been saved. And here, when we get back to the Unity, we have a compiling process, a fast compiling process, and now our code is ready. And you can see the preview of your code here. Right, you can now assign your code, your script, or your custom component to any game object you want, or add an empty game object here and drag and drop your simple code here, or press add component and search for the simple code. Actually, we have many types of components here. For example, in the physics, we have all these components, effects, audio, and so on. In the scripts, you can find your simple code, your custom component actually, and assign it to your game object. The question is, can you assign a code multiple times? Yes, you can assign it multiple times, infinite times actually. Right. Now we can play the game. I think we don't have any camera in the scene. So in the game view, it shows the display one, no camera is rendering. Here I need to add a camera, right? And this is the camera view. And I will explain about the camera component later and how to configure it and change its attributes. But let's change its position for now. Alright, and play the game again. Okay. As you can see, nothing happened. So let's start coding process. I want to write a very simple code. I'm going to print out a string or message to the output. So where's the output in Unity? In the console, you can see all outputs, warnings, errors, and actually the custom messages. Here in the Unity, you can log out any message you want. I will try it in the wake, start, and update. Alright, we have two ways to log out a message in the console. The first one is the print method, and you can write a message here in the double code. It's a string actually. You can write everything you want. You can log out a number or a float number if you want. It is acceptable in the print, or you can use debug class and then log method if you want. And the structure is similar to the print. I will use print. It's simple to write. Alright, I will write it is awake. I will write another print here. It is start, and I will write another in the update. It is update. Right. Actually, I can remove this comments in the C# if you add double slashes and write everything you want, it will act as a comment and it will not work as a code. Right, let's save, and here the compiling process. Alright, now play the game. As you can see, it is awake logged out at the first. As I said, the awake method is the first method in the Unity that will be executed. The next is the start method. It is start, and the next is update method. And as you can see, the count of the update execution is increasing. Actually, as I said, update will be executed every frame, and you can see the message is growing up. Actually, 20 seconds after execution, we have this count of message. And I enabled the collapse, and you can disable it. And as you can see, we have all your messages, not count of your messages. And here you can press collapse, and actually you can press clear, and here we have new messages. All right, you already know about the awake, the start, and update, and a simple print and also debug.log, and how to log out something in the console. In the next chapter, I will focus on the C# and actually a C# refresher. I will explain about methods, classes, variables, axes, levels, and so on, and the differences between monobehavior classes and regular classes, and all the differences between the C# scripting in Unity and regular C#. Before proceeding, I need to say, if you want to access to all chapters of the course, you can get it for free from blackcave.com/n/tutorial. Also, you can get access to other courses related to the 3D rendering, 3D modeling, and also game development. You can get access to many tutorials and extra chapters, advanced chapters of this course. Also, at the final, you can get a certificate and add it to your resume. Also, the link is in the description. Welcome to Unity 6 Part 6. In this video, I will talk about the C#, actually the C# basics, and also the differences between regular C# and the C# provided by the Unity, actually the C# script. In the previous chapter, I've explained about the awake, start, update, and some basics about the C# scripting, but I will start from scratch in this chapter. Let's remove all of these methods, and here let's talk about the data types. Maybe you know about the integer, float, string, and so on, but I want to talk about the concept of data types and what actually a data type is. We have many type of variables. For example, byte number 1, which it gives I think 255 maximum, and the next is int or integer number 2, float number 3, and you need to write a f word at the end of the float. Double, which is a kind of float, but it will gives a bigger number, and you don't need to write a D or F after that. String str, boolean be triggered, for example, and so on. All these data types, byte and float and so on, actually are classes or structs. I don't want to deep dive into this concept. What are the differences between classes and structs? All these data types are structs or classes, and these are actually objects, and sometimes we call them variable. When we clone from a struct or a class, actually we're creating an object. If we press Control and left click on a data type, we can see its structure. Here we can see the double is a struct. Struct is a simpler version of class. They have some differences, but in a simple word, we say struct is a simple class. So the question is, can we create our custom data types? Yes, data types are classes or structs. So we can create our custom classes or structs. Here we can see the simple code is a class. So it's a data type. And we can create an object based on this class. For instance, simple code and S. And we can create a class based on it. But here, after equals sign, we can't assign a number or string to it because the structure of the class is custom and we need to pass some different values. We didn't say give a number or give a string or give a true, false, or boolean from us. It's a custom object, so we need to put a value in a different way and a custom class. Actually, the content of this simple code class, these variables, these objects, and we can access to these variables and actually methods defined in this simple code with this object directly. Actually, it's an example. I just want to say we can define objects from classes and structs everywhere we want. We are inside this simple code class and we're defining an object from this class. It is possible. And actually, the memory assigned for this variable is nothing, it's null. And if we print out the content of this object, we'll print out null. Null means nothing. We need to put something in the S variable or object. Actually, this is correct. We can put a null value inside it, a null keyword inside it. It means nothing. If we don't write anything, it is null by default, but we can put something inside it. We can use the new keyword to assign memory for this simple code object and then write the simple code class again and add parentheses. Here actually we create a new object and assign a piece of memory for this S object. Actually we can access to content of the simple class right now, but we have some limitations because of the monobehavior class here inherited, simple code inherited from monobehavior class. I will explain it later. Let's declare a new class everywhere we want. For example, here at the bottom, or create a new script and define a class dir. There is no limitation. We can create several classes in a C# script, a single C# script, but we can't create a class inherited from monobehavior several times in a single C# script. But it's easy. Public, I will explain about at the access levels in this video. A public class, for example, human. And here we have a regular class not inherited from monobehavior, and we can declare our objects, methods, and so on in this class. And here in the simple code, we can create an object from the human. Right, as you can see, we have a new object and we can access to anything defined in the human class from here. But we need access levels, means everything inside this class should be public if we want to access them here. For example, we want a method or variable object to access from here. We need to define them in public. Or, for instance, we can make this private and we can't access the private class here. Alright, actually the classes and structs are very useful for better structure and organized projects. Actually, we have a big concept called data architecture or design patterns, that all of them are not applicative without classes, structs, inheritancy, and so on. For example, we have to define everything related to the human inside this class. For instance, public int health. The default value of this health is 0. The default value of int, if we don't assign a default value like 10, is 0. Alright, here how to access to the health. We can access to the human content and the methods. Actually, methods are the instructions, and we need to write our instructions and logics inside the methods. You know about the awake method right now, provided by MonoBehavior class. And here we can access to the health variable from this human. Human dot health. I've accessed to the health variable easily, and I can print it. Let's see the result. Save and play the game. Alright, as you can see, the 0 number has been logged out. We can change the health, or we can assign a default value. Right, human health equal to 100. And now let's play the game again. As you can see, the 100 has been logged out. Actually, it's not correct to define everything inside a class. For example, we create a class called player for player movement, player rotation, handling the health, handling the player shoots, player weapons, and so on inside a single class. It's not correct. We need to organize it. Actually, we have mobility in this case, and we can easily use the predefined classes again in another project. If you write everything in a single class, and you have actually a first-person shooter game, and your next game is a third-person or strategy game. So you can't use your FPS class, which is a single class, health manager, and everything inside it in your new project, because your code is useful just for first-person projects, not strategy or third-person projects. But if you use classes, you can use the human class inside your strategy project, because the human class manages the health and some human related jobs, and easily you're splitted your jobs into classes, and you can use each one of the classes you want for your next project, and you don't need to write everything from scratch. And actually debugging and other works are very easy in this case. Right, let's talk about the custom methods. Here we have a method I explained about a void take damage, and take damage will decrease the health, and we will decrease it 20 units, and we can print it out after decreasing it. But print method, it's not available in the regular class. Actually, print is available in the MonoBehavior classes, the classes inherited from MonoBehavior, and here we can use debug .log. Alright, here I want to combine two concepts together. I want to write health is and combine the health variable with this. I can use a plus sign and health. Here it will show actually the health is 100, and if we call human dot take damage and parentheses to call the method, it will decrease the health 20 units, and we have 80, and it will show health is 80. let's try and comment out this print or remove it completely. Alright, play the game, and here as you can see the health is 80. And this is good. Alright, if we change the public to private, we can't access to the health variable, it's not accessible. But we have other access levels, for example internal. Internal means we can access to the health, but we can't access to the health outside the solution. This question may raise, can we access to a variable outside the C# solution? Yes, we can access, but using internal, we can't actually access to the health outside the C# solution, this file. I will use internal keyword a lot in my projects, and because of that I've introduced it. We have other access levels that I will introduce later. For example, protected. We can define this as internal as well, and this is good. Let's talk about the mono behavior. Let's actually remove these lines. Here we have the mono behavior, and using mono behavior we have many capabilities in C#. For example, one of the best capabilities are we can assign our component to any object in the scene. But if we remove the mono behavior easily, here let's see, as you can see we have an error because we've assigned the simple code, and here we have a problem. Actually, this is not problematic, and we can remove the component, and here we don't have any problem anymore. But we can't assign the code because it's not inherited from mono behavior. Actually, mono behavior is a big class related to Unity stuffs. And if we want to assign our code to the scene, we need to use mono behavior. And actually, this awake method is custom right now. It is not inherited. This is not a method that execute at the first, and actually it not works because we're not inherited from mono behavior class. And start, as you can see, update and other methods are not available anymore. And this awake method is custom, not inherited. But if we write mono behavior, here we can assign it easily to any game objects we want. But you can't write mono behavior here and make the human inherit from mono behavior because it will be confused, that Unity will be confused. Actually, we are dragging and dropping the entire C# script to the game object, and Unity can't recognize which one of your classes you want to assign, and confusion will be happening. The next step is the custom input parameters. Here we can give a input parameter, for example an int, and damage, and decrease the health by the damage, not a static or hard-coded value, for example 20. And here we have an error. We need to pass a damage to the method, for example 30. And we can receive any parameter we want, for example bool b damage, and check the b damage. If b damage was true, then decrease the health. Else, or else if, health should increase and add the damage to the health, not decrease it. Here we need to pass the true. Right, we pass decrease 30 units for the health, and the damage is true. Let's see the result and play the game. As you can see, we have 70 value. Alright, let's talk about the returning value. Actually, this void means this method executes something and ends. But if we write a data type, for example int, bool, float, and everything, it will return something just like this data type to the color. Actually, this is color, and we can receive a result from the method. Here we can write bool, and here we have an error because it says you need to return something, and here return true, for example, and true result will be returned to the color. Here we'll call take damage, and after the execution process it will return true, and here we can receive the true result. Here we can save the result in a variable b result. Actually, I'm used to use b word before the main name of the boolean. The b stands for boolean, and it's arbitrary. Actually, I'm used to. Right, and we save the result. We can print out the b result and see what the output is. Play the game, and you can see the true. Or we can return false. And also, we can directly print out the method, the result of the method. And here it will print out true. No matter you save it inside a variable and execute some operations on the result, or print out the result, or directly print out the result in a single line. Also, you can easily return an int. Here we can return health and print out the health. Let's see. As you can see, the health is 70, and this 70, if you double click on a message, it will redirect you to the specific line. Here the second 70 is related to this section. Also, we can define another human here, and it's different from human, the first human. Actually, this is the benefit of the classes. If you don't have classes, you need to write this logic for another human. We have a human2 dot health equal to 200, and print human dot take damage to 20 and true. Let's change this as human. I need to change it to human2. Alright, let's see. Play the game, and this is the result, the first human, and this is the second human. The last subject I want to explain is the constructor of the class. When you create an object from a class, you write a parentheses. A human is not a method, and parentheses is useful for methods, not classes and objects. Actually, in this step, you are creating the object, and in this step, you are calling the constructor. Human is the constructor method. Actually, in C#, when you create a class, it will automatically create a constructor method in background, and you can't see. But you can define your custom constructor. Constructor is a method like this, internal or public. Actually, the class is public. Let's declare the constructor method public as well. And don't define a name for the constructor. It should be human. And this is the constructor. Actually, by calling the new human and then parentheses, you are calling this. And as I said, C# is automatically defined the constructor in background. But actually here we are redefined it. And having a constructor is arbitrary, but calling it is necessary. Here, let's debug .log something. Human object is created. And let's see, it should log out something because we are using the constructor, we are calling the constructor. And here, let's play the game. And as you can see, 2 human objects created have been logged out because we have 2 objects and we called it twice. Actually, the constructor can receive parameters, for example, health, and we can pass a health to a constructor and set this health to this. And here we have error because we need to send something, a health, to the constructor. We need to send, for example, 100 and 200. And here we can remove this and assign this to this health. But they have same names. We can change the parameter name, but actually we can use another technique called this. This keyword means this class, and call health. Health means this. And if we call health without this, it means this parameter. Actually, we are setting this health to this parameter. And now we can remove this and see the result. Let's play the game. And as you can see, health is 70 and the second human is 180. And actually, constructor is working. These are the C# basics, and I try to explain about the differences between C#, regular C# and C# script in Unity. In the next chapter, I will deep dive into the C# scripting in Unity. I will explain how to modify the scene, move an object, modify the game objects in the code. Welcome to Unity 6 course part 7. In this chapter, we're going to introduce more features and more capabilities in C# script in Unity. And I want to deep dive into the C#, to the scripting aspect. We already know about the printing and logging out the messages to the console. Let's integrate the code to the Unity. For example, we want to apply a modification to the game object. For instance, setting it active, setting it deactive, here, changing its name, moving it, and so on. And this is the integration between the C# and the Unity. Let's start from the beginning. Here we have a code that we have read in the previous section. Let's remove them. As I said, if you want to add your script as a component to a game object, you need to inherit from MonoBehavior. MonoBehavior gives this capability that you can drag and drop your component, your script, to a game object and add properties, specific properties to a game object. Here we have a subject called field, which, when you add your component to a game object, for example, this camera, we have some fields. For example, this projection is a field. Field of view axis is a field. Field of view is a float field with a range. Clipping planes near is a field, is a float field without range. Physical camera is a boolean. So we can add many types of fields. Here, let's create a public. Public means, maybe you know about the public and private. Public means other scripts can access to this variable. Private means other scripts doesn't have this permission. But in Unity, public gives you another capability. It gives you a field. For example, we have a float field called speed. Control S and go to the Unity. Alright, click on the game object and you can see a speed field which is float, and you can change its value. You can change it to other types, for example bool, which is a boolean, true and false. As you can see, it's bool, and you can active or deactivate it. Right, if you make it private, you can't see it anymore, and the field capability is available only in public, but we have some exceptions. Public objects, public variables are not so protected, and they have less security, and other codes can access to them. Your priority must be making all the variables private, and in some cases you need to change it to public. But what if we want to access to the variables as fields in Unity while and at the same time the variable be private? How to do it? We need to add a square bracket and type serialize field. Serialize field add this capability to see this private variable, this private object as a field in the Unity, and you can see the speed. Let's go further, change it to int and type awake, and here print out the speed, no matter it's float or int. Here we want to see the speed and change it to 31 and run the game. Actually, the code is depend on the input you entered here, and as you can see 31 has been logged out. And here if we drag and drop our code and set it to 15, here actually we will see 31 and 15. We have one code, a single code, but we can use it infinite times on game objects and set different values. Actually, it's a type of object-oriented programming, but in a different vision. We can add custom classes, create custom classes, and create objects and have a object programming, traditional object programming in Unity, while we can use MonoBehavior and add components to the game objects and achieve this benefit, not using the traditional object creation. Unity can handle this by dragging and dropping the components to the game objects. Alright, let's ignore the basic data types. Let's create a game object. Game object type, which it refers to these objects, and we can assign each of these objects to the game object field. Actually, number or boolean is not accessible in this field, and here let's change its name to obj, and let's print it out, and it will log out the name of the game object. Here, let's see. As you can see, let's remove this component. As you can see, we have a game object field. We can press this circular icon and pick one of these game objects in the scene, or you can drag and drop a game object to this field, and it's filled out. And here, when we play the game, we can see the name of the camera. As you can see, the camera is locked out. It means this field is not empty, and we have the camera inside it. And we can drag and drop any object in the scene to this field. Alright, and now let's write another thing. Work with the properties and methods provided by the game object class. You can see the structure of the game object class if you press the control and left click. Here you can see it at the game object class inherited from object class, and you can see the structure of it. If you write object dot, you can see all the properties and methods provided by the game object class. Here I will introduce some important properties and methods. For example, setActive. setActive makes our object active or deactive. Here we must pass a boolean, true or false. If we pass false, it will deactivate the game object. If we play the game, you will see the camera will be deactivated. As you can see, we don't have any vision because the camera is deactivated, and its text, it's gray, not white, like directional light, audio source, and so on. And this little icon, which refers the activation of the game object, is unchecked, and here it's checked. We can activate it manually again or deactivate it, but you already know how to control it in the code. What if we write this code in the update method? what happens? Actually, it will run the deactive method 60 frames, 60 FPS per second. Actually, it's an infinite loop and it will not end. And actually, we can't set it active because we'll deactivate it again, and again, infinite times. And we can't activate it again because we write this code inside the update. Update is a loop. I introduced the update awake start in the previous chapters. All right, let's remove this line, and here access to other properties and methods provided by GameObjects. Call object and name. You can access to the object name, which is a string here. As you can see, it's string, and print it or change it completely. You can change it to, for example, my camera, and see the result. The name is camera. Let's see what happens after this renaming. Let's play it. And as you can see, its name has been changed. And you can change the name of the game object in this way. Alright, let's go further. We can check the activation of a game object like this object active self. Active self is a Boolean property which it is read only. It means you can't change it, you can't write into it. It's read only, and it will return the activation of the game object. For example, we can write a condition. If the game object was active, print the object is active, else the object is not active. See the result. Alright, play the game, and as you can see, it says the object is active. Let's deactivate the camera and play again, and the object is not active. Actually, using the active self, we can check the object activation. Alright, these are the main and most important properties and methods provided by the GameObject class. I will introduce more capabilities of this class later based on our needs. We have another subject called GameObject with lowercase g. What is this? It's a property and different from GameObject type, GameObject class. It's a property provided by MonoBehavior. As I said, when you inherit from a class, the public properties and the public methods will be inherited from the upper class, the parent class. This game object comes from the MonoBehavior and actually refers to the current game object. You add this component to it. Actually, it refers to game object. If you add your component to the camera, it refers to the camera. If you add your component to the audio source, it will refer to the audio source. And if we call setActive and make it false, let's see the result. It should deactivate the game object, this game object. Let's see. Object is not involved to the scenario, and as you can see, the game object is deactivated. And you can refer to the current game object using the game object with lowercase g. It's a property. And the last and actually the most important part of this chapter is adding components dynamically. Here we can call add component no matter you are calling the game object with lowercase g or object. This method is available for the game object class. Actually, it's a type of game object class like the object here, no matter which one you use. You can call the add component and you can add component dynamically at the runtime. Here after that we need this sign and write the type of the script or component you want to add. For example, you want to add an audio source or simple code or actually light, no matter what component you want. For example, here you can write simple code, this code. Is it possible to add a component a couple of times? Yes, it's possible. Actually, the simple code has been added to the game object, and we can add another simple code using code or dragging and dropping the component inside the editor, no matter. And here, call the method. Actually, add component is a method, but this section is useful for generic methods, and I will explain about generic methods in the future chapters. It's more complicated, and it will add polymorphism capability to your codes. I will talk about the polymorphism and generics. Alright, press Ctrl S and see the result. Play the game, but it's not a good code because it will add an infinite loop to your Unity. Actually, it's a trap because it will add another simple code component, and the new simple code component adds another simple code component, and it will create a loop for you. And actually, it's working, but it's a trap and infinite loop. And actually, it's better to not do it. You can add another component, for example, audio source. Alright, let's play the game. Here, as you can see, an audio source component has been added to the game object dynamically. You can add infinite components dynamically. And don't write this add component code inside the update because we'll face to an infinite loop like the previous scenario. We can add this component to the object, which is the camera, and any object we want. In the next chapter, I will introduce how to move, rotate, and scale an object using the code or even using the keys on your keyboard or mouse. Welcome to Unity 6 course, part 8. In this chapter, I will explain about how to move an object and work with the transform component. How to rotate, how to move, how to scale an object in different ways. So let's get started. Here in the code, we need to remove these lines, which I explained about them in the previous chapter. Now I want to explain about a new class to access to the transform component of each object. Here, as I said in the previous part, we need to define everything as private because for the safety of the data, in some scenarios I will make some variables and objects public. Private, the class I want to introduce is transform, and I'll name it tra. Alright, this transform, we can drag and drop and assign a transform component from a game object to this field, but I need to make it serialized field to make it accessible in the inspector. Alright, when we select the game object, as you can see, we have a transform, and we can drag and drop the camera. As you can see, it filled out with the transform component related to the camera. We can drag and drop the game object itself, audio source, or any game object in the scene, no matter. And we can modify the transform component of each object we want. For example, we can change the position, fields X, Y, and Z, rotation, and scale. If you want to move, rotate, and scale and modify the transform component at all of current game object you've attached simple code to, you can access to an object provided from MonoBehavior class called transform with lowercase t. It's not a data type. Actually, it's an object, just like game object with lowercase g, which I explained in the previous part. Now we can get access to all the features provided by the transform class. No matter you call the tra or transform, both of them have same capabilities, same properties and methods. All right, I will work with the transform later, but now I need to work with the tra. And for this field, I need to drag and drop the cube because cube has a 3D view, 3D virtualization, and I can move it easily. When I move it, I can see the changes easily. All right, first let's start with the position and moving the cube. If we want to access the position property, we need to call the position. And it will give us this three fields, X, Y, and Z. But how? How does it give us three values? Actually, the type of the position is vector tree. Vector tree is a type that receives three values, X, Y, Z. When we get access to the position, we can write a dot, and here we can access to three fractions, X, Y, and Z. Now we can print. Let's print one of them. All right, save, and here we need to run the game. Right, let's see. It will print the X position of the cube. Here, minus 2.04. And here, let's see the cube. As you can see, the X is correct, is similar to the output. All right, how to change the position? Actually, to change the position, we need to create another variable, serialized field, private vector tree of type of vector tree, because position needs a vector tree. And here, pose. Here we can call tra and position equal to pose. It is easy. Actually, it will put this position vector tree to this position. Save, and here we need to fill out the fields related to the vector tree here in the game object. As you can see, we have three values just like the transform. Here I will make a tree 1 and 0. All right, let's see. As you can see, it has been changed. Here cube is in the new position. That's good. Now we know about moving the object, and we have another method to move the object. Translate method. Translate method receives a vector tree input, and it has 6 variations. Actually, we have 6 translate methods. One of them receives a vector tree. The second is vector tree and a space type. And the third variation is the transform, and it will move the object based on another object, and so on. Here we will use the simplest one, and we put the position. Let's see. All right, now play the game and see the result. All right, what happened here? Why this cube is placed here with these values? These are my values, but cube placed here. Actually, in Unity and all game objects, we have 2 methods to get the values, the transformation values. The local transformations, the world transformations. So, what are the differences? When we drag and drop the cube on the game object, for example, actually now this is the parent of the cube. And here, if I select the cube, as you can see, we have different values. The previous values were these, and after that, after reparenting the cube, we can see these values. They're different because these values are relative to the parent, the game object, and since the game object doesn't have any parent, it's under the world. Actually, the transformation values based on the world transformation. And this is the local transformation. Actually, we can change the world transformation of the cube as well, but the priority in this case is local transformation. Because of that, we have different values. Here in the translate method, actually we can, for the second parameter, we can send a type of space. Space is an enum, and I will talk about the enum later. Actually, if I write space and dot, we can set it to world or self or local. When we set it to world, it will move the object based on the world position. If we set it to self, it will change the position of the cube based on the local position. So currently you know about the local and world positions and transformations. Now let's talk about the translate. What is the difference between the translate and changing the position directly? Actually, translate will add the numbers position, the x, y, and z in the position in this variable to the current position. For example, if the cube was here, it will add the values and cube goes here. And if you add again, it will go here. It will add the values to the current values. But with the position, you have more management on the moving object. Actually, you're replacing a new value to the current value with tra.position equals to pose. We are replacing actually. But here it's different. Here, let's see, it's -3. Here, this is 3. It will add the -3, -3.3 to the 3. Let's play. And as you can see, the -0.3 remains. And actually the add operation happened. And here, this is the final result. And y is 3 plus 1. It would be the 4.7. And it will work in the local position. If you want to move it based on the world position, you need to use the second parameter in the translate method. Alright, in summary, you will replace the position in this method, and the second method an add operation will be happened, and the pose will be added to the current position based on the local transformation, not world. And here, let's write it in the update, and it will add this pose every frame to the current pose. Here, let's see, but we need to decrease the values defined in the pose here because it's too high, which it will add frame by frame. It's good. Instead of y, because it goes up, let's copy and paste to z, and 0 for y is better. Right, let's see. As you can see, cube is moving. And it's adding these values frame by frame to the current value. Here, as you can see, the x, y, and z is changing. Alright, we can write negative values, not just positive numbers. Right, now let's talk about another property provided by the transform. It's local position. Actually, if you want to access the local position relative to the parent, you can get the local position and change its value. If you want to change the world position, you need to call the position. And we have the local position in the opposite side. Alright, now let's work on the rotation. If you want to change the rotation of the object, you need to set a new value to the rotation. And actually the rotation receives a quaternion, not vector tree. Quaternion has some extra capabilities for the rotation because the rotation process is kind of more complicated than moving and changing the position. And quaternion has 4 values: X, Y, Z, and W. W actually a helper axis that is very helpful for some works such as gimbal angle. You can read about it. It's actually related to mathematics, and I don't want to talk about it in this video. And you need to give it a quaternion. Here we need to change this to quaternion. Rot equal to rot. It's kind of similar to the position. And I don't want to talk about the replacement. Here, as you can see, we have 3 values, not W. As I said, W is a helper, and it's better to not modify it yourself. Actually, it's recommended, and it will not give it to you in the inspector, but you can change it here. As you can see, we have X, Y, Z, and W. You can change the W in the code, not in the inspector. Here, the rotation of the cube is 0, 0, 0. Let's change it to 45, 90, and 20. Alright, as you can see, the rotation, the exact rotation, is the values we've entered in the game object here. But in some scenarios, if we go beyond the 180, for example 190 or 200, we will see an artifact. As you can see, we have the negative 170. What happened? Here, the W involved to the process and actually will not support some specific values, and it will change it based on some calculations related to the rotation in mathematics, and you will not receive the exact value you have entered. And you need to change the rotation in different ways, and I will introduce those in the future, in the next chapters. They are related to the advanced transformation stuffs, and this video is not good for covering them. Just like the possession, we have the local rotation, which we can change the local rotation of the cube based on the parent relative to the parent. And here we have a method called rotate, and it will receive a vector tree. The question is it possible to rotate an object using the vector tree, not quaternion? Yes, it will change the vector tree to quaternion automatically, and you don't need to involve to the complicated stuffs, and it does look like the translate. It will add a number to the current number, to the current axis. For example, here we pass through rot, but we need to change it to vector tree. And here we can also give it an angle to prevent from the issue we have faced here, that we have entered 190, but it changed it to negative 170. We can work with the angle. I will talk about it later. And here we have the space and so on. Actually, we have another variation of the rotate method. Also, we have it in the translate as well, which we don't need to send a vector tree to the method. We can send the X, Y, and Z separately without creating a vector tree. But it's not ideal when you work with the transformations in Unity. Alright, let's test. Let's change this to a small number. Alright, let's play and see the result. As you can see, it has been added the one value for each axis to the rotation. Let's move this code to the update using the Alt key and directional keys on the keyboard and see the result. Alright, as you can see, the cube is rotating and it's very good. And it will handle the rotation, as you can see, between the positive and negative values, and it's related to the calculations and mathematics, and it will handle it automatically. Right, rotation is done. The next is scaling. Scaling is easy. We need to call the local scale. We don't have scale, just scale. Local scale. And you can give it a vector tree. Just it. Let's test. We have these values for the scale. Let's change it to 2, 1, and 3. Let's see. Right, as you can see, this is the cube with these values and this shape. Right, the scaling process is easy. For the last aspect, I need to say something. If you want to give a vector tree a quaternion to local scale, rotation, position, or local position, and so on, you can make a new vector tree variable in the runtime, actually in the wake or update. Here we can do it instead of using this variable, predefined variable. You can write a new keyword just like the previous chapters. Actually, when we make a new object based on the class or a struct, we need to use the new keyword and call vector tree. And here vector tree receives 3 values, 3 variations of the vector tree of the constructor of vector tree have been exist. The first one is the empty vector tree. It will fill out the x, y, and z with 0. The second variation is sending the x, y, and z will be 0. Third variation, you can fill out the x, y, and z. Here we can send 3, 1, and 0. And here we can test it, and we don't need this variable anymore. Here let's test. And as you can see, this is the result. 3, 1, and 0. Based on the values we've entered in the code. Be careful when you use new keyword and creating a new object, because if you do it in a critical and complicated method like update, which it will run every frame, it can affect on the memory performance, because when you use the new keyword, it will allocate a space on the memory, and actually if you do it every frame, it's correct. When the method ends, it will remove the space. Let's see. It will remove the space allocated for this vector tree, and the memory will be removed and free. But at the next iteration, it will allocate a new usage, and it will affect on the performance, and you may face with some lags in the gameplay, but actually not with a simple line like this. If you write many lines like this with new keyword, you may face with some issues. These are the basics related to the transform, and you already know about how to move, rotate, and scale the objects in the scene. In the next chapter, I will explain about inputs and how to get the keyboard and mouse inputs from the user, move, rotate, and scale an object using the input keys. Welcome to Unity 6 course, part 9. In this chapter, I will explain about the inputs and receiving the mouse and keyboard inputs from user, and move an object or print something in the console using a key, a specific key. Right, here we have only the update method, because we need to get the input in the update, not awake or start, because it will check the user input every frame. If we write the input and the wake start, it will receive the user input only in the wake, in the beginning of the game. It's not correct. Alright, Unity 6 offers two input system. The new input system actually, I'm not used to it and it's not useful for me actually. The first input system is better because you can have more management on it and customize it. For getting any input, you need to call the input class. Input class offers many methods. For example, get mouse button, get key up, get key down. But the question is, how can we access to the methods provided by the input class without creating an object based on the input? Because in the previous chapters, we saw we need to define an object based on a class to access to the properties and methods. But how can we access to the methods provided by the input directly without an object? These methods are static methods. If we control and left click, as you can see, this is static methods or static properties are available globally without creating a new object based on a class. I will talk about the concept behind statics, but you already know about if you put the static keyword before the name of the method or property, you can make it available globally and you can access it without creating a new object from that class. Alright, we have three main methods to get keys. The first one is the get key, and we have three variations. Get key down, get key up. Get key means it will execute everything if until a key is down. For example, if I press the Q button on the keyboard for 3 seconds, it will run a code for 3 seconds for almost 180 times every second. We consider every second 60 frames. 60 multiplied by 3 is 180 times. The second method is get key down. It will run your code once when your key down. And the next is get key up. When you release a key, it will run once. So how to get a specific key? Actually, get key down, and get key up will return a bool. So why bool? If the key pressed, it will return true. If the key not pressed, it will return false. Now we can call the get key, and here we need to use key code. Key code is an enum. As I said in the previous chapter, I will explain about the enum. It will give you some choices and you can select between 2 or infinite number of choices. Here, if we press dot, we can access to all the keys on the keyboard, on the mouse, Android or iOS, touches, and so on. Here we can press Q, and we have a boolean here because get key will return boolean, and bool be pressed. We need to save it, and we can print the be pressed. Here, let's see. Play the game, and here, as you can see, we have the false return value. Now we can press the Q button, and I'm pressing the Q button. And as you can see, we have this message. I release it, I press it, and you can see the result. Let's test the key down. Play the game. Right, it's false. I'll press the Q. Alright, as you can see, I'm pressing the Q key, but it's false. It will print out the true ones. Right, let's test the key up. And here I'll press the Q. As you can see, we don't have any true, and I release it. Here, as you can see, we have a true ones. Right, you already know about the get key, and we can access to all the keys through the key code enum. Here, let's explain about the second type of method, input.getAxis. I don't want to talk about the getAxis raw for now. I just want to cover the getAxis. So what is the getAxis and what it receives? Actually, it receives a string, which is the name of the key. But how we can realize what the name of a specific key or a specific axis? And I need to say it will return a float. So why a float, not boolean? So go to the edit, project settings, and here in the input manager, here we have axis. It's a list, or we can say array, of many keys. Actually, these options here are the keys. We can create a new item and give a 1, 2, 3, or 4 keys to each axis. Here, for example, horizontal, it is useful for horizontal keys, this direction I'm mentioning, which you can get the A and D keys. And vertical is related to W and S keys, vertical axis. As you can see, the horizontal key has a name which you can change it. It's horizontal by default. It will receive 4 keys: negative button, positive button, alt negative button, and alt positive button. So what is the negative and positive? Actually, when you press the right direction button on your keyboard or D button on your keyboard, it will return a positive value. As you can see, it will return a float. It will return a positive float number. And if you press the left direction or A on the keyboard, it will return the negative number. And the number, the final number, will be in a range of -1 and 1, not beyond that, not -2 or +2. You can remove this or change it, and you can easily change any key you want. But you need to be careful, know about the exact name of each key, because you are inserting a string and we don't have a list of keys and you can't select between them. And every key should be written in lowercase style. I don't want to talk about the gravity dead, but you can set a sensitivity. What if you want to move your mouse? So we can change the sensitivity of the key, and if you have 10 number for the sensitivity, and if you move your mouse, you have a higher speed, and when you have 1 for the sensitivity, you have a slower speed. So it affects on mouse, on joysticks, not keyboard keys, because keyboard keys are triggered type, and we have 0 or 1. We don't have, for example, 0.4, 0.5. But for mouse, we have. For joysticks, we have. But for mouse, we do. For joysticks, we do. So if you move your mouse and get mouse movement value, it may return a float value, for example 0.1, 0.2, and maximum value is 1. And you can change the type of the key. It's key and mouse, just mouse, or joystick. These are the most important sections about the axis. We have the vertical SW and up and down directions for the fire or shoot, for the jump, and mouse X for the horizontal moving of the mouse. And here we don't have any keys because mouse movement is related to mouse movement type. And X-axis, as you can see, horizontal axis, it's different. The definition of the mouse is different. And the mouse Y, as you can see, the mouse movement, but Y-axis, it will access to the vertical movement of the mouse. And here we can change this number to 31. And here we have a new option. Press Ctrl Z, and as you can see, we lost it. And here we have an extra field, and we can change its properties and create a new key and rename it to everything you want. So using the get access, we need to write the exact key we want to access. For example, horizontal, let's copy and paste it here. And print, we need to define a float, horiz, and horiz. Let's see. All right, play the game and see the result. It's 0. If I press D, as you can see, now it's 1. Actually, it smoothly goes to 1. Let's press D again, and as you can see, we'll start from this value and increases gradually, and here we have 1 value. All right, press A, and as you can see, it will return -1, negative values actually. All right, this is the get access, and the last type of method is get button. I will not introduce it in depth. It does look like the access, but it will return a bool. It's a combination between get access and get key. Actually, you need to give it a string, horizontal, vertical, mouse X, and so on, and it will return a boolean. And we have the get button down, and get button up. I don't want to cover it. And beside that, we have the get mouse button, but I will not talk about it too, because we can get access to the mouse buttons using the get access and get key, and we don't need the get mouse button down, up, or empty get mouse button. Let's move an object using the get access and also get key and compare them. Here we need to write a condition if input.getKey keycode.w. So move the current game object. We can access the current game object using the transform property provided by MonoBehavior, as I said in the previous chapter, and call the translate method and move it in the let's see, the cube in the x or z axis. I prefer x. Here I can create a new vector3 object here, but I prefer to define a variable vector3 here because, as I said, if you use the new keyword in the update method a lot, it will make your game laggy, and I prefer to define value here positive pose, and here another vector3 for negative pose, and here I need to pass the positive pose because W should move the cube and every object in the positive direction, positive X. Else if input.getKey keycode.s, if it was s, translate to negative pose. All right, let's see. All right, the question is, game object is empty and cube has a mesh, a 3D model. So we call the transform here, which means this game object to current game object, which the symbol could attach to. If we move the game object, the empty game object, we don't see anything. It's incorrect because when a parent moves, the children will be moved too. Actually, the game object is empty, but the cube is the child of the game object and it's moving as well. And we can move the cube separately. All right, let's set a value for the x. For example, 0.01 and minus 0.01. Here, it will pass these two values to the translate, and it will add the positive to the current position and and this scenario will add negative position to the current position. Here, let's start. Alright, press W, and as you can see, the cube is moving, and S, this is the value, and you can see the X. It's decreasing and it's increasing. Right. For the exercise, you need to write the A and D, or even jump using the space key. Here we can access to space. Write the jump logic. Alright, let's implement the logic with get axis. Here we can check the get axis horizontal if it will return a float. If it will bigger than 0, so it is D key. So move the object in the positive position. Let's see. It's different from get key. It will return a float, and we need to check the exact number. Right, as you can see, it moves. But I have a better idea to make this line to a single line, because we need to add the logic of lower than 0, and we need to pass the negative pose. So we have 4 lines of codes, and we can make it just 1. Here we need to get rid of the condition. Here we can create a new vector tree, or we can use the other variations of translate. Here we have a specific variation which we can send the x, y, and z separately, not using the vector tree. Here for the x, we can call the input.getAxis and horizontal. We'll send the A and D keys as a float. Actually, this axis is float, and the get axis will return a float. So if we press the D, it will send 1. If we press the A, it will send -1. So we have a correct logic. And for the rest of it, we send a 0 for the Y and Z. Let's test and see it works or not. Alright, play the game. And as you can see, it's so fast. And the cube is here. We need to decrease at the returned value, because the maximum value is 1, and adding 1 to the translate every frame makes the process too high, and the moving process too high. And we can define a float variable called speed, and here multiply the horizontal returned value by the speed. We need to set the speed to 0, 0.01, 0.1, because if we have the 1 result and multiply it by 0.1, we have the 0.1 as the result. Actually, we are dividing it. Alright, now we have the logic, and let's test. Alright, we have the speed here, and we need to set it to 0.01. Let's test. Alright, as you can see, we are moving the cube smoothly and very good. For the last work, we can move the z-axis as well. Z-axis should work with the W and S. Here we need to call the input.getAxis vertical and multiply it by speed as well. The only 0 in this list is Y. And here, if we wanted to write this logic using the if and else, we needed to write 8 lines. But with this logic, we have just a single line. Alright, play the game. And here we have the W, D, A, and S with a single line of code. Alright, these are the main principles of getting inputs from the keyboard and mouse, and you already know about them. In the next chapter, I will explain about the physics and how to make a character movement correctly. For example, a first-person character or third-person character correctly using the physics, not just simple movement of the objects. Welcome to Unity 6 course, part 10. In this chapter, I will cover the physics and collisions in Unity. Actually, the collisions and physics cover character movement, generate collisions between the environment entities, and so on. Here I need to introduce something. Here if I select one of the objects in the scene, as you can see we have a box collider here on the mesh. Actually, this is the collision component which it can prevent from other objects to go through it, go inside this object, and actually this is a physical object. Now if I remove this, as you can see, a green border has been removed. Here a green preview of the collider, and here we can go to the physics tab and we can access to many colliders and physics stuffs. For example, box collider, capsule collider, character controller, which is useful to implement the character movement logic for FPS character, first person character, third person character, and so on. It is a cloth for cloth simulation and so on, and the most important colliders are mesh collider, box, capsule, sphere collider, and these are the main colliders in the Unity, and I will cover them. And the next important section is the rigid body. Rigid body actually simulates the bouncing, the physics and bouncing and gravity for a specific object, and it's heavy to compute actually, and it's better to use it in some specific cases, for example for the character, for important objects in the scene. And for the rest of the objects in the environment, just a collider is useful. I'll explain about all of them soon. First, let's start with the colliders. If I select the box collider, it will shape based on the mesh shape. And as you can see, these green borders represent the box collider. And if I remove it and scale the object in the x-axis and add another box collider, as you can see, it's shaped just like the mesh shape, the mesh main shape. If I add another collider, physics, and if I add a sphere collider, for example, as you can see, it's not shaped as the object shape because it's not a sphere object, and we can say it's intelligent and it will recognize the shape of the model. So the best shape for this 3D object is box collider. Actually, we have another collider. It's mesh collider. It will shape completely based on the object, no matter it's a cube, sphere, a cylinder, or a face, a human face, and that's a complex object. And if we choose a mesh collider for a face or a creature model, it will shape based on the vertices on the mesh. Here we can select mesh collider, and here we have some options. The first one is the convex. If we check it, here we have a collision based on the model or mesh structure. Now it has physics, and other objects can collide with this cube, and no matter which shape we have. If we go to the game object, 3D object, and sphere, as you can see, based on these green lines, it has a sphere collider. And now we can remove it and go to the physics and add a mesh collider and press convex. As you can see, it's a complex collider and it will shape based on the 3D object. shape. I will talk about this trigger, provide contexts, and other subjects. Actually, they are not related to this video. In this video, I will talk about the physics basics. Let's remove the component and talk about the other gliders, box glider. Here we have this trigger, provide context, material. As I said, I'll explain them later. But we have the edit glider, which we can edit the glider, make it bigger or smaller. Using these points, as you can see, we are increasing the range of the glider. And the mesh glider, we didn't have it because the mesh glider is kind of complex and intelligent. It doesn't have any specific basic shape, and it doesn't offer these points. All right, here with the center field, we have three subfields X, Y, and Z. It is the position of the glider, and here we can change the X, Y, and Z. If you put the glider here and another object, if moved toward this object, it will glide here, not here, because the main glider is placed here and object is a preview of the shape, not, it doesn't have any physics by default. Alright, the next field is the size. We can increase the X, Y, and Z easily. At the center, it is different from edit glider. Here we can change, it's not symmetrically. Actually, if we change this point, the opposite point doesn't change, but with the size we have this capability. Alright, the next glider is the sphere glider, and it is similar to box glider in a way. We have the edit glider here. We can change the points. Here we have the center. We can change the position, radius. We don't have size here, and it is the important sections of sphere glider. The next glider is capsule glider. It is look like a capsule. But if you want to see the complete shape of this glider, you can add a capsule object here. As you can see, we have a capsule glider, just look like the capsule shape. And here we can change the attributes of it. Here we have the edit glider, we can change it. And as you can see now, it's look like a capsule. The next is the center, as you can see. The next is radius and height. We can change the direction as well. The direction now is the y-axis. We can change it to z-axis. Here, if we increase the height, as you can see, it's along the z-axis, x-axis, and y-axis. Actually, y-axis is useful for humanoid characters because it is look like a human body. All right, let's add a box glider, and the next, let's add a sphere glider for this, and next, a rigid body. I want to explain about the gravity, the collisions, and so on. If you had two gliders and make a collision, for example this sphere with box glider, we don't have see any effect, any collision effect, and in this scenario we need a rigid body. Rigid body actually simulates the physics, gravity, and collisions, and at least one of your objects should have rigid body to see the physics simulation. Add a rigid body, and I will explain about the properties. Let's play the game and see the effect. You need to play the game first. Alright, as you can see, we have the gravity and the sphere falls down. If we move it manually in the scene view, as you can see, we have a collision. and actually a pressure on the sphere, and sphere couldn't go inside the cube because of the box collider, and it has a physics simulation. And as you can see, we have a force and a pressure on the sphere, and a collision has been applied. Let's select the global transformation, and here, as you can see, we have this effect, and here, all right, as you can see, it's stopped. And the scene view, we can do funny stuff, and we can control the sphere. For instance, as you can see, this sphere can't go inside the cube, but if we add a pressure, and as you can see, it goes inside the cube. But in the game view, if we do it with the controlling keys, for example, WSAD for your character won't go inside the objects. Don't worry about it. But in the scene view, we can do many stuffs, and it is a testing mode actually. As you can see, we have the gravity, the physics, pressure, force, and so on. We can do this works inside the code. All right, before starting the physics in C#, let's introduce the most important parts and the most important attributes of the rigid body. All right, let's start with the mass. Mass actually is how heavy the object is. If I set it to 10 or 20, means we have a heavy object. And actually, it's harder to push or stop. If an object with a value of 1 collide with an object with a value of 20, actually the heavy one will barely move. The next one is linear damping. Linear damping is air resistance for movement. So, in a simple word, with this value, lower linear damping value, if you slide your object, in this case, the sphere, on ice, it goes far. But if you set it to a high value, it stops quickly, just like moving on a grassy surface. And the next is angular damping, or air resistance for spinning or rotation. This look like the linear damping, but it applies on rotating. The next is automatic center of mass. When we check this option, we'll find the balancing point of the object automatically. Actually, consider the best point where the object can be balanced. And it's a very important aspect for applying physics. And the automatic tensor is related to the automatic center in a way. And automatic tensor means how easy it is to spin it around different axes, like a pencil. Consider a pencil, the center of it, and if we want to spin the pencil, we can easily spin it from the center, and it's easier to spin, and actually the pencil position still remain, but the rotation is changing and is spinning around itself. Actually, automatic tensor will find the best point automatically. The next one is use gravity. It's obvious what it is. Actually, we saw it in the scene, and we have a gravity effect on the objects. The next is kinematic, and in a simple word, makes the object ignore physics forces. And if we want to move the object ourselves in code or animation and so on, without considering the physics rules, we can activate this, and we can move the object using the keyboard keys and so on, but still collision remains for the object, and our object actually doesn't deactivate the rigid body completely. It has a collision detection. The next is interpolate. If we want a smoother effect for our object, for example, we're moving the object using the W key, and when we release the W key, and if we put it on none, it will stop quickly. But interpolate and extrapolate, I will explain about them and different. They will stop the object smoothly. The next is collision detection, and we have the continuous, dynamic, and speculative. Discrete will apply the collision detection every frame, and it is not good for sensitive stuff. For instance, character movement, which our character can collide with walls, objects, and so on every time. And checking the collision every frame is not enough. And our object can pass through the wall if we apply more pressure or more force, and it is not good. So we need to activate one of these continues. I will explain about them in future. And continues is CPU heavy, but it will apply more collision consideration and more checks every second for an object. But consider to use these three options in some specific cases, for instance, for a character. The next is constraints, and we can lock the object in three axes, lock the position of the object, or lock the rotation. If we activate the X and Y, this object won't move, and physics doesn't affect on the X and Y positions. I don't want to cover the layer for now and for this video. So in the next step, let's work with the rigid body in the code. Here in the code, we need to use the rigid body class. Here, let's create a serialized field, private rigid body. We have rigid body 2D for 2D games, but as our project is 3D, we need to use rigid body, and rigid body with lowercase r is the best name for this kind of variables. I will explain about the naming and the naming rules in a different video. Here, if we write the rigid body and dot, we can access to many methods and properties. We can see some familiar properties, for example, center of mass, collision detection mode, angular velocity, automatic center of mass, and so on. And you can change every attribute of the rigid body from the code. For example, you can check the surface, and if it was a grassy surface, you can change the linear damping to a higher value to lower the sliding effect on the object. If it was ice surface, you can make it lower to apply a higher value of sliding. We have access to some methods, for example, add explosion force. If we want to implement a grenade effect or everything that has explosion, you can use this method to apply explosion effect. And you need to specify a force with a float value, explosion position, you need to pass a position of the explosion effect, and so on to apply the explosion effect on the objects in the scene. The next is add force. I want to cover this completely in this video. Actually, explosion force is not very important for this video, and add force is more important. Here in the add force, we can pass a force as vector tree. For example, if we pass this value, it will add a force with a value of 1 for the x and y and z are 0. So we don't have any force in these two axes. And we can add any force we want. And we have 4 variations of the add force here. The first one receives a force, just a vector tree. For the second variation, we have force mode. For the third version, we can ignore passing a vector tree and we can pass x, y, z separately. And the fourth way is to passing the x, y, z separately and force mode. So what is a force mode? Force mode is an enum. I will explain about enum, naming rules, and some kind of advanced features of the C# in the future videos, but I will give you some options that you can choose between. Actually, the force mode is the type of force to apply, as you can see. A regular force, the acceleration, which starts fast and it will slow down, velocity change, impulse, and so on. I will explain about them later and we will use them based on our requirements. I don't want to cover all of them. But the default is force, the regular force. Here let's save and try. Right, here we need to drag and drop the simple code, and here we have a rigid body field. We need to drag and drop the sphere, and it will detect the rigid body and put it inside the rigid body field. Here let's play the game, and you can see a force. Alright, as you can see we have a force, a value of 1 for the x-axis, and it falls down. Alright, we can do it with keyboard input just like the object movement. Here instead of 1 we can get the input, get axis and horizontal. The horizontal is A and D. A and D. Horizontal. And for the Z, which is this axis, we can get the vertical. And let's see how we can control the sphere using the keyboard keys. Right, in the game, I press W, and as you can see, we have an object movement, but it's different. And here, if I release W key, as you can see, our object is moving because it has physics apply on it. And it is hard to control actually, and we need to adjust its attributes, the rigid body attributes. For example, we can increase the linear damping, and here let's try. And if I move the object, it's hard to move, but it stops quickly. Alright, these are the basics of the rigid body, but I want to say something. For the final spec, we have a way to get the components using codes, and you can ignore here dragging and dropping the object itself in a field. We have the rigid body here. It's not necessary to drag and drop the object here. We can use and we need to use this process in awake or start. Let's do it in start. We worked with awake a lot. We can fill the rigid body with a method, a specific method get component. Get component will get a specific component with a type you specify inside these two signs, and we need to get the rigid body. We need to type a specific class, a class we want to get from the current game object, and call the method. It will get the rigid body component attached to the current game object. Alright, set it to none, and we don't have any rigid body, and C. As you can see, the rigid body has been filled out, and we have the sphere here. Alright, we already know about physics and rigid body. In the next section, I will explain about the character controller here. Character controller, which is better for applying the character movement, character rotation, and so on. It has many features related to the characters, and it's very useful for every character, no matter it's humanoid character or a creature. Welcome back. In this chapter, I want to explain about the character controller in Unity. And actually, character controller is a physics and collision component, which is very useful to implement a character movement, FPS character, first person character, or third person character, or any character movement stuff. And it is different from rigid body and regular object movement, and it offers some capabilities related to the characters, just characters, not general physics like rigid body. So here for the character movement, here add component and go to physics, and as you can see, we have a character controller component here, which is mixed with colliders and physics like rigid body. But it's better to assign it to a capsule. As I said in the previous parts, capsules are very useful for making characters, humanoid characters, because of its shape. Here's the head, a human head, hands, body, legs, and it is look like a human. And character controller, let's remove the capsule collider. Here, character controller is look like a capsule, and it is better to assign it to a capsule. Here we have some properties related to a controller, and let's explain the most important parts of it. Alright, the first one is the slope limit. So what it is? Actually, it is the maximum angle of the slope that the character can walk up. For example, if the slope is steeper than 45 degrees, your character will not be able to climb it and will be stopped or slide down. A value of 90 would allow climbing vertical walls, while a value of 0 would mean the character can't climb any incline. So it is 45. If I change the ground to this angle, this is higher than 45 degrees, it can't move up, and I need to change the slope limit of the character. And this is one of the benefits of the character controller. It can automatically detect the slope. Here the next is the step offset. Actually, this is the maximum height of a step that the character can step onto without jumping. For example, if a stair or ledge is 0.3 meters high, for example, the character will automatically walk up it. If it's taller, the character will be blocked. It is very useful for platforms and stairs and controlling them. And the default value is good. The default value for the slope limit actually is good as well. The next is skin width, and it's a small distance that determines how far the character's collider can sink into other colliders before being pushed out. Actually, a larger value makes collision detection more stable and prevents the character from getting stuck. And if it's too large, the character might appear to float slightly above the ground. Actually, a value between 0.01 and 0.1 is good. The default value is good and works. The next is mean move distance. The minimum movement distance that must be requested for the character to actually attempt to move. This value works, and you don't need to change it. But in some specific circumstances, you need to change the properties. For example, slope limit. If you want to create a character like Death Stranding, you need to increase it, because we may face with many mountain stuffs and hills, and the value of the slope limit must be increased in those cases. The next is the center or the position of the collider. Here we can change the X, Y, and Z. You're familiar with it. I've explained it in the colliders section. Here we can increase the radius. If I lower it, as you can see, the height doesn't affected by the radius, but with the higher values, the height affected by the radius. And here we can change the height. And I don't want to explain the layer over it. It's a general field that I will cover later. As you can see, it exists in the other colliders. Right, let's write a simple code to move the character using the horizontal keys and vertical keys. Here, let's add a new script. Call it character movement. Here we have the start and update by default. Right here we need to declare an object of type of character controller, right, and name it controller. In the start or awake, we need to get the character controller component. I wanna assign this code to the capsule, and here let's assign it at first. And here we can call the get component method to get the character controller. I've explained about the get component in the previous part. Controller equal to get component and the type of component we want to get, character controller, and call it. Here we have, let's save it. We have the character controller at the start. Let's play and test. Here it's a field. Let's play. Alright, as you can see, we've get the capsule character controller. Right, and update, we need to get the inputs and move the character because we want to execute it every frame. Here, let's call the controller, and it has two main methods, move and simple move. Actually, we can change the properties of the controller, for example, slope limit, min, move distance, and so on. But the method we want to use is move. And we need to pass a vector tree, just a vector tree, to the move. And here we need to pass the vertical for the Z, and it is a forward, or you can pass for the X, vertical for the X, W, and S keys. I'm gonna pass the vertical for the Z axis and the horizontal or A and D keys for the X axis. In the previous chapter, I've explained about moving the rigid body using the vertical and horizontal key. And if you don't know about the horizontal, vertical, and physics, you can watch the previous sections first. So here we need to create a new or inline vector tree, new vector tree, or we can declare a vector tree up here. For the X, I need to get the input dot get axis horizontal. For the Y, 0 is good, and for the Z, I need to input get axis vertical. Alright, this is not similar to the rigid body, and we don't need to get the current character controller or object Y axis and position and set it here. Actually, move is similar to the translate method in the transform class. From the transform class, it will add a value to the current position of the character based on the physics, and it will not ignore the physics. Looks like the translate method. From the transform doesn't affect on the physics, and it's not based on the physics. So here we need to save and execute the game. Here, play the game. Here, let's play the game, and as you can see, I'm moving the capsule collider with W, S, and D. We don't have gravity here. Actually, character controller doesn't have a gravity feature, and we need to implement the gravity ourselves manually. and it's not too complicated. First, we want a gravity multiplier, a value that multiplies by the y-axis, because we want to apply the gravity based on the y, along the y-axis. So we need a multiplier that that's the force and the speed of the gravity. Here I need to declare a variable, a float, and call it gravity player, and the value I'm using in my project is negative 30.81 F. And you can use other gravity values. You can search on the internet and use some constants that physics offer you. Here we need a property called velocity. Controller has a velocity. Velocity is a speed and a value that every axis has. For example, if we move the character in the x-axis, we have a positive velocity. If we press A key, because the horizontal keys are related to the x, if we press A key, we have a negative value of the velocity for the x-axis. And if we call the velocity property, we can get the axis speeds and use. But I don't want to use the velocity of the controller. I want to declare my velocity. The velocity is a vector tree, as I said, and name it velocity. Here I want to change this velocity and set the character to this velocity. Actually, with calling move, we are changing the velocity property of the character. So here we want to change it again, but I will use this field just for gravity. Here the only axis I want to change is the y. So I need to call the velocity dot y, because the gravity should be applied along the y-axis. So we need to call the y and use the plus equal, because I want to add a value to the current value of the y. So the value I want to add is the gravity multiply. And here we need to call the controller.move again, but this time for gravity and the y-axis, not for the x and z. And here we need to pass the velocity, and this vector tree will be added to the move, and the x and y is 0x. Alright, let's see. Play the game. Alright, as you can see, the capsule is not on the air. Let's move it, and as you can see, I can't. We have a gravity here. I can change the position of the plane, and as you can see, the capsule is coming with it. And I can reduce the force of the gravity and change it to this value and try again. Right now we made it slower. As you can see, the capsule is falling down slowly than the previous value. Another concept is a time.delta time. Time class dot delta time variable. It's a float variable that gives us the execution time of every frame. It's not constant because every frame can be vary, and the execution time of every frame can be vary, and we can multiply this value by delta time, or this value by the delta time, to synchronize execution of the character movement, because the character movement is a sensitive work and we need to do it based on the delta time. Consider we have frame drops in the games and some issues, and actually we have a constant character movement speed for each frame, and this is not good. We need to multiply this, for example, this variable for a frame as 0.001. So we need to multiply this by this vector tree, and it will synchronize and normalize the value, and it will change this character speed based on the frame rate. And this is very useful technique. It is necessary for every game. So here we need to multiply this vector tree by time dot delta time. The question is, can we multiply a float value by a vector tree? Yes, it will automatically multiply every axis, x, y, and z separately by the delta time. And the vector tree values will be affected by this value. So we need to do it for the gravity as well. And now let's test. Our target is to normalize the speed of the character. Alright, here in the game view, if I press the controlling buttons, the moving buttons, as you can see, the character movement is slower because we multiplied it by the delta time, but it is variable and it will change based on the frame rate. And let's test the gravity as well. Alright, it is good. Also, we can declare a variable called speed, float movement speed, and set it to 1. Here we can multiply the vector tree by the movement speed at first, and next the result multiplies by the delta time, and it will normalize it. Here also we can modify the speed of the movement if the movement speed is not enough for you. Alright, here we can change it. Let's play the game and change it at runtime. Alright, as you can see, we have a movement. Let's set it to 3, and here this is faster. Right, we can make it more advanced and add a shift key and get the shift key using the get key down or get key up. And if we press shift, we can set it to 6 or 10, and if we release the shift key, it will set to 1 and revert it back. And here we have a running instruction in the code. In the next part, I will explain about how to make a more advanced character which has a camera. I will explain the camera, changing the character direction based on the camera, and so on. And in this chapter, create an FPS character, first-person character in Unity. In the previous part, I've explained about the character controller, and we've designed and write a code to move the character controller easily. Let's play the game and test it. Right, as you can see, the character is moving, but I wanna improve it. I wanna add camera at the top of the character here, because we should consider this is the character, this is the character's head, and we should place the camera on this point, which is the character eyes, and we need some extra calculations for the movement algorithm. For example, character should move and change its direction based on the camera. For example, if I input the mouse X here, this direction of the mouse will move along the y-axis, and actually this rotation should be applied on the character controller, on the object. But if I input the mouse Y here, this direction, the character shouldn't rotate in this direction because actually I'm rotating the character itself. I should rotate the camera for this direction. For the X direction, I should move the character itself along the y-axis, and for the mouse Y, I need to rotate the camera along the x-axis, and I need to orient the character to the appropriate direction and change it, because when I press the W key, it will move along the Z or X-axis, actually the forward direction. And if I don't change the character direction based on the rotation, and if I press the W key, the camera looks at this direction, for example, the forward is this direction, but the character is still in this direction. The character forward is this direction, the previous direction. And we should implement this logic. First, I need to remove these lines, and I don't need to remove this line. The gravity and everything is good. Actually, I need to keep the gravity. It's the gravity code, but I need to create a separate method called apply gravity, and copy and paste these lines here and call it firm update. And here we have the gravity effect applied on the character controller. In the next step, I need to create a method private void movement. Right here, I need to write the movement logic. I need to get the horizontal and vertical and hold them and store them in variables. It is better an organized way. You can write it inline like the previous chapter, but I prefer to create an x input dot get axis horizontal and float y input dot get axis vertical. Alright, we have the x and y axis, and now we need to calculate the direction. When I press vertical keys W and S, I want to move the character in the Z direction. Actually, the Z direction is the forward direction in Unity, the forward of the object. Here it's the forward, and the X direction is the right direction. Here, if we write transform, the current object we write, we attach the script to it and press dot. We have two properties, forward and right. Right will give me the value of the right direction or X direction, exact value. It's 0, it's 1, 2, 3, -1, -3, and so on. And the forward will give me the exact value of the Z direction. So I can here multiply these values, these x's, to the inputs. If I press the A key, the horizontal value, the x value, will be a negative value. And multiply by the right direction. As I said, the right direction is the axis, and I need to move it with the horizontal keys. And if I multiply this value with the right direction, it will be turning to a negative value. And if this value was positive value, the character moves to the right side. So here I need to call the transform.right multiply by x. But we have a problem here. We need to store and hold the result inside a vector tree, because the right is a vector tree and multiplies by the x, all x's, x, y, and z multiply by x, and we need to store it inside a vector tree variable. So what about the forward? Because move method, character controller dot move method, receives just a vector tree, not two vector tree, and we can't calculate the right direction and already a separate vector tree variable, and forward direction multiplied by y, and inside another variable. We can't. We have something that we can write plus and transform dot forward multiply by y. Here, with this operation, actually we combine these two vector trees and we have a unified result. Here we can store it in a vector tree move direction. Now we have an appropriate calculation. Here we can call the controller.move and move direction. And we need to follow the previous steps. Multiply the direction by the movement speed which we can adjust the movement speed, and finally multiply it by time.delta time. In the previous chapter, I've explained about movement speed and time.delta time, the logic of it. If you don't understand this concept, you need to first watch the previous chapter. Right, save the code and let's see. If I press W, actually I forgot to call the movement. Excuse me, we need to call the movement in the update. So now it's executable. Alright, as you can see, I can move the character, and it's slow. I need to increase the movement speed. But now let's work on the camera and add the camera as a sub-object of the character controller. We just need to drag and drop the camera into the capsule, and here let's rename this capsule to player. We need to change the position of the camera here, or here instead of manually changing the position, we can make it 0, and it will go to the center of the player. Actually, this position is a relative position, it's a local position, and if we change it to 0, it will change based on the player or this capsule center. Here we need to move it up, and actually this is the character head, character eye. I recommend don't move it forward. The center section is better. X should be 0, Z should be 0. It's better. I recommend it. And if you want a appropriate first-person character, you need these values. Don't move it forward, backward, right, and left. Alright, let's write the logic. First, I need to define the character camera. Actually, in Unity, we have a camera class, which this class related to this component, but I don't want to use the camera class because I want to change the rotation of the camera, and we need to define a transform. We need to get the transform component of the camera. So here we need to define the transform and camera. Here we have a green underline. What is this? Actually says camera movement dot camera hides inherited member component dot camera. Use the new keyword if hiding was intended. Actually, the MonoBehavior give us a camera variable just like the transform with lowercase t, game object with lowercase g. It will give us a camera with lowercase c. Actually, we redefined the camera variable because MonoBehavior has camera variable. So if we want to redefine the camera, we need to write a new keyword. Here, after private, we can write new, and the green underline has gone. Alright, let's define a method called camera rotation, and now we need to get the mouse X, which is the horizontal movement of the mouse, and mouse Y, which is the vertical movement of the mouse. We need to define the float mouse X input dot get axis mouse X, and float mouse Y input dot get axis mouse Y. Now we need to rotate the camera only along the X axis, not Y and not Z. So we just need a float, not vector tree. Here in this case we needed a vector tree because we need to move the controller along the X and Z. But for the camera, I need to rotate the camera only along the x-axis. But instead of defining the variable, the rotation value inside the camera rotation, I need to define it up here because we need to store the previous values. Each time we call the camera rotation, the new variables like mouse X, mouse Y will be gone, and actually they will redefine and they will set to 0, and we don't need this for the rotation because we need to keep the last rotation value. So here we need to call private float and Y rotation. I want to use something that we need a permanent variable that we need to keep the last rotation value. So here we need to minus the current Y rotation from the mouse Y, vertical mouse, or you can use plus. There's no different because if we move up the mouse, the value would be positive. If we move down the mouse, the value would be negative. And we have a simple math operation. Here we have the final rotation, and now we just need to rotate the camera. But the trick is here. We call the camera, and here plus dot, but we need to change the local rotation because camera is the sub-object, is a child, and we need to rotate it along the relative or along the parent. And in this case, we need to call the local rotation. But local rotation receives a quaternion. There is a way to change easily, and defining a quaternion and setting the W, the handler, the helper axis is kind of hard and needs some calculations. But we have a helper method that we can convert a vector tree to quaternion. Actually, we give to that method a vector tree, and it will change it to a quaternion. Here we need to call the quaternion struct. Struct, as I said in the previous chapters, is a simple class. We can say it's a simple class and lacks some features compared to classes. Here we have a method called Euler, and Euler receives a vector tree and change it to the quaternion. We can create a new vector tree here, inline vector tree, or easily has three values as x, y, and z instead of a vector tree. It acts like a vector tree without creating a new vector tree. As I said, creating and using new keyword each time in the update heavy to compute and adds a pressure, adds a whole overhead to the memory, and some issues to memory defragmentation. And here in this case can use three values. Here I need to send the Y rotation for the X axis because I want to rotate the camera along the X. So for the other axis I need to send the 0 and 0, Y and Z. So we have the three values. Now let's test, but before that let's call the camera rotation in the update. We need to get the values and get the inputs and rotate the camera in real time. Alright, before playing the game, we need to assign the camera. We can't use get component because camera is not a component of the player. It's a completely separate game object. We have a way to get the children, but for now this method works. Alright, as you can see, I'm moving at the camera, and we can move the character itself very well. Now we need to apply the character movement. As I said, we don't need to rotate the camera along the y-axis. Instead, I need to rotate the player along the y-axis. Here easily we can call the transform. We don't need to follow this instruction. We can, but it's not necessary to define another variable called, for example, X rotation and follow these instructions. We can easily call the rotate method, which it receives a vector tree, and here, just like this formula, here we can send something with this directions right forward. But we have another property called up, right forward and up. Up in positioning is the Y. But for the rotation, as you can see, Y is this direction. And this is the up direction for the rotation. And we need to call the up direction if we want to rotate it along the Y-axis. Rotate an object along the Y-axis. Here we can't write transform dot up because it will give us current transform up direction based on the position. I want to rotate it, not move it, and based on the up. But what we need to do if we can't use the transform dot up, because it's variable, this right, this forward or up will change based on some circumstances. We can call vector tree the vector tree struct, and here press dot, it will give us forward, right, and actually up. It's a raw up value. It won't change based on the character circumstances. It's a constant and it will give us this value. Vector tree, as you can see, 0, 1, 0. We can define a vector tree and put this value 0, 1, and 0. This is same, just looks like the up direction. We can do it like this, but it has overhead. And vector tree has a constant called up. It will help us to prevent from defining a new vector tree and use this up. But if we use the up variable provided by the transform, actually we have different values every frame. And here for the multiplier, for the speed, can multiply it by the mouse X, the horizontal mouse. If we move the mouse like this, the y-axis will be changed. Actually the character will be rotated along the y-axis. If we don't write the multiply mouse X, it will rotate continuously, and we have an infinite rotation, and the mouse input doesn't affect on the result. Alright, let's save and play the game. Alright, as you can see, we're moving the mouse, and actually the character direction is changing. As you can see, if I press W, it will go forward. If I change the rotation of the camera and I'm pressing the W, and the forward direction is changing as well. Okay, if we need to apply the rotation speed and time the delta time, just like the movement speed, here we multiply the move direction by the movement speed and time the delta time. Question is, can we use the camera rotation speed and time the delta time and the camera rotation? Yes, but easily multiply this mouse X with a value. Let's define a value. Serialized field, private float, camera rotation speed, and the default value should be 1. It's better. Right, and multiply by the camera rotation speed, and then multiply it by time, that delta time. It is possible to do it for the movement. It's mean move this section to X and Y. Yes, it is possible. But as we have just a single line, one line for the movement, and we have a single calculation for the move. And if we move this section up here, actually we doubled. We make it twice calculation, and it's not good. But for the camera rotation, we have already 2 calculations, one for the camera and one for the player, and it's irregular. If we move this line to here and this line here, actually we make it complicated, and it's better to apply these calculations here. And we have the speed. For the final touch, we have a problem. If I play the game Actually, for this direction, we don't have any range. Can move it, and here we have an infinite move. And it's not good. It doesn't have any range. The human neck, the human head does not look like this. We can write a logic for limiting the rotation. Here we have a class called mathf and a dot clamp. We have a method called clamp. Actually, clamp receives a variable limited between a maximum and minimum values. Here we need to pass the y rotation as the main value. It should limit. And for the second value, we need to send the minimum value the y rotation should set. For example, negative 90. This value. This is negative 90. A camera can't rotate beyond this value. And for the positive, I need to set it to 90, positive 90 for the maximum value. And clamp has a return value float. We need to store it in the y rotation itself. It is possible, right? We've actually limited the camera rotation and play the game. Here we need to set the camera rotation speed. It's very low. It's not good. This value works, or maybe more. Right, as you can see, it doesn't go beyond. Alright, this is very good, and we have the right logic. Right, good, we have a first person character here easily. Okay, in the future chapters I will explain how to implement the jump logic and actually more advanced features. For example, if we jump, we can't move anymore, and we need to check the character if it's grounded so we can move, and if not, so we can't. Right, see you later. If you want to access to all chapters of the course, you can get it for free from blackcave.com/n/tutorial. Also, you can get access to other courses related to the 3D rendering, 3D modeling, and also game development. You can get access to many tutorials and extra chapters, advanced chapters of this course. Also, at the final, you can get a certificate and add it to your resume. Also, the link is in the description.